Good morning, Antonio. Good morning, everyone. We are starting soon with this third edition of Concordia Open Door event. I hope, just checking if you can hear me, and I will start like in 1 minute. Perfect. I would say we can start. So hello, everybody. So my name is Antonio Caglianillo. I'm here in the virtual stage with the video Mihaila. And welcome to this new edition of Concordia Open Door event. I hope you're well, even if the world is facing this global pandemic. As European cybersecurity stakeholder, most of you already know Concordia, but I want to spend just a few words to highlight our objective. So Concordia mission is to lead the integration of European cybersecurity competences to enhance the European digital sovereignty. So we are achieving this in several tasks and services. You can also check them on our website. And in this framework, 2 years ago, we started the Concordia Open Door event series. So Concordia Open Door aims to connect stakeholders of all backgrounds and let them discuss critical topics for the growth of the European cybersecurity community. Unfortunately, this pandemic forced us to organize our third edition on a virtual venue. But please don't be intimidated by the platform. It can really help us to overcome the limitation of virtual meetings. So you can interact, first of all, with us, with the speakers, through the live chat you can find like on the right of the screen. But you can also chat with other participants. And we also have like an exhibition area where you can find like booths and posters from our partners. We also set up like in some virtual launch to meet up between or after the session when you can chat with other participants in real time. So if COVID was not a thing, this year we would have been in Bucharest, Romania. So Bitdefender, one of our partners, would have hosted us, but since this was not possible, they are hosting us virtually through this platform. So I want to thank them on behalf of the whole consortium and personally for arranging such a venue. Thus, before starting with our first session, I would like to give the floor to Ovidiu Mihaila, Bitdefender's Innovation Funding Manager. Ovidiu, the floor is yours.
Thank you, Antonio. Dear guest participants and speakers, on behalf of Bitdefender, good morning and a very warm welcome to Concordia Open Door 2021. As Antonio said, we started this discussion some time ago, I think 2 years actually, because we tried to do it last year as well in Bucharest. Unfortunately, the pandemic situation wasn't allow us to proceed with the physical event. Then we thought that this year we'll get better with the whole situation, but unfortunately we are still online. Again, it's a pity that we couldn't meet live face-to-face in Bucharest and enjoy a bit the physical interaction, and then also try to discover Bucharest, because it's an important European city. But I do hope that if the things will get better, and when the things will get better, we can actually meet and sync live. Going back to Concordia Open Door, we have interesting panels across the 2 days, today and tomorrow. We'll talk about next generation cybersecurity, also how the cybersecurity community actually can support and help the ECCC. And also we have to celebrate at the end of today Concordia Women's Award ceremony. I will not go further with describing what you should expect from today and tomorrow, because I'm more than convinced that the topics are very interesting. Once again, thank you for being part of this event. And also I would like to thank Antonio and Bitdefender team for actually putting everything together, even online. So let's have an interesting discussion. Thank you, Antonio.
Thank you again, and thank you for these words. So I will immediately start replying for the first question from the question and answer session. So what is the time schedule for virtual booth? I don't see it in an agenda. So well, the virtual booth are already open. You will find people in there, like in the virtual booth. I hope, I would say between the morning and the afternoon session, so during the lunch break, and at the end of the day after the last session. So, but now I would like to give the floor to Professor Anisetti. He's going to give us our first keynote, namely is Concordia Threat Landscape Finding and Next Step. So this talk will present the status of cybersecurity, focusing on the gaps and the challenges and the novel research direction. So Marco, the floor is yours.
Thank you, Antonio. Let me share my presentation. Okay, I hope that you can see clearly.
Yes.
Okay, thanks again. So the scenarios we are coping with in these days for analyzing threats and giving some kind of landscape to threats, it's really challenging, and it's a really changing playground as well. We have different technologies in place like IoTs, 5Gs, Edge, and also big data that is shifting the importance of need to know, need to share versus the privacy issues that are normally coped with data. The system is becoming more and more distributed than before, and we are leading to some kind of fully or partially lose of control. And also in this scenario, trust is really becoming more and more important, and confidence in IoT systems is leading to the scenarios where transparency and continuous integration, but also verifiability of quality of service is becoming very important as well. The system is more layered than before. We have different layers that are used in order to provide functionalities, and with the layers we have to address different security requirements and features that are offered by the different layers. This will have an impact in the attack surface that is becoming more, let's say, fuzzy than before, and also we have different heterogeneous actors and devices, maybe different regulations. Some of them are lacking of informants that could be used in order to deal with security issues. We also have to cope with untrusted providers and also untrusted collection of data. This is also connected to a multitude of security requirements that is normally connected to a complex scenarios like the one that I'm presenting. So having this scenario in mind, we divided the scenario in different domains that are the 6 domains of interest for Concordia, and we defined our threat landscape for each of these different domains that are network, system, application, data, IoTs, and device and user. For each of these scenarios, we're elaborating on the current state of the art for producing an outlook of emerging threats and evolving attacks. The methodology that we used in order to obtain this result is starting from the asset that we identified in each domain. We produce the different threats, analyzing the state of the art, and connect them to the attacks, linking them also to the asset that are referred to specific attacks. The outcome is a document where we have listed all the threats connected to the different domains, organized into different threat groups in order to have the possibility then to do some kind of cross-cutting analysis. At the very end of this process, we identified 32 threat groups and 83 threats. Now there are more than 90 the threats that we have in our threat landscape, because the threat landscape itself is a live document that is continuously evolving, connected to the different technologies and situation that is evolving as well. For instance, while doing our analysis, we cope with the impact of COVID-19 in the threat landscape, and I will go through this in a moment. We also release different versions of this document for a generic audience, so to speak, in HTML version, and we also have a navigation tool that allows you to navigate through the different threat groups and domains and threats, and even to download and propose modification on this threat landscape. Out of this, we identify, let's say, a list of key takeaways that are connected to these threats in a more generic way. So let me go through them. First of all, we experience a number of persistent threats that are there since the beginning for more than a decade. These threats are becoming more endemic than before due to the fact that we are experiencing new assets like IoT devices that are weak compared to the cloud ones. And this allows the persistent threats to still have a way to impact a system through the IoT devices that are weaker than the other one. But we are also seeing some trend of evolution in terms of distributed denial of services that are now more capable to have an impact on the system thanks to the diffusion of mobile device with some kind of computational capacity to carry out a more effective distributed denial of service. Another effect that is quite important to analyze is the impact of the different specific domains constrained with the different security requirements. So while coping with some security issues, the countermeasure that you can put in place depends on the domain and specifically the application domain, for instance. So not all the countermeasures could be applicable in the specific domains. So the fact that you have to cope with domain-specific analysis prior to deciding which are the security features to have in place is a kind of balance that have to be addressed in order to decide which type of security countermeasure could be used. And this balance is also normally driven by business-related issues like the time, the budget that is devoted to security that is needs to be also in line with the type of analysis and the type of system that is going to be developed. So, for instance, in case of IoTs, we see that some kind of cryptography could be aligned with the limitation of IoTs, like in case of lightweight cryptography. But this depends on the application domains where IoT is applied. So IoT is also opening to new insider threats, which is connected to the physical access to device that cannot be easily bypassed with the security protection that we have currently in place. And this is also exacerbated by the new ultra-wideband networks that is kind of new attack vector with giving that is capable to give to the attacker a new, let's say, capability to do synchronous attacks and low latency attacks that could be under the, let's say, could be one of the way to provide capabilities to do a localized distributed denial of service with more high impact than the prior distributed denial of service systems. Then the network itself is now becoming more softwareized than before, and this improves the large data surface with new software components that are part of the network. So a network is no more a facility, but is a kind of service that could be used to develop an application, and this makes the things even more complex, exposing to new software-related issues at networking level. Network is also bringing the capacity to provide more distributed systems where the computation is also distributed, like in case of edge computation. In this case, we have also not just the application that is somehow migrating to the edge, but also data that could be sensitive and analyzed in the periphery that is not normally power enough to have all the security features in place, like in a cloud centralized environment. And this is connected to the increasing adoption of artificial intelligence models that nowadays computed in the edge. So in scenarios where security is less cannot be as let's say as power than in the centralized environment. But artificial intelligence itself is a booster for cybersecurity attacks. So it's not just a target of a cybersecurity attack where you may want to attack a training set and stuff like that, but it's also a way to provide a more tailored and focused attack to the systems thanks to the capacity of artificial intelligence to learn how the system is working, etc. This is connected to user profiling. So user profiling is something which is there since the beginning of ICT, so to speak, but is now granted on more, let's say, power tools like artificial intelligence that allows to have a more fine-grained profile, and this will permit to have a more targeted spam campaigns that we are seeing these days, and this is also connected to what we have in our house as more smart devices that are powered by artificial intelligence themselves and full of data that could be used for profiling purposes. Profiling is also connected, for sure, with social media and social network threats that are a source of data for profiling, but we are also experiencing scenarios where artificial intelligence is capable to replace human interaction. And during the pandemic, for instance, there is an increase in adoption of these scenarios for political propaganda or spread of disinformation. The system itself is not just moving through the artificial intelligence capacity, but is becoming more and more layered, as I mentioned in the scenarios at the very beginning of this speech. But these layers always, let's say, impact or always rely on a virtualized environment. And in case of virtualization, these days we are seeing, let's say, an increased number of adoption of virtualized environment with a very dense, let's say, multi-tenancy adoption of virtualized systems. So any type of weaknesses or vulnerabilities of virtualized environment could have a higher impact while this virtualized environment is used in a multi-tenancy scenarios, because you can have access to data from different of different users being access to the same physical machines. So this is becoming even more severe than before, and we saw that layered systems always cope, even if there is a trend to go back to the let's say hardware, but the trend of virtualized environment is improving as well. This is also connected to misconfiguration of security mechanisms, because the system is becoming more and more layered, and this means that each layer has to cope with specific security features to deal with, and so configurations to enable security features and keep control on this configuration is quite complex. We saw some examples in the very recent attacks to Facebook. There are also typical, let's say, threats connected to business process compromise, but these threats are becoming more and more diffuse nowadays due to the transition to the cloud. That makes this business process compromise threats more difficult to be achieved. Let's say more difficult to be analyzed due to the movement to cloud environment with third parties into the business process. and we are experiencing issues related to humans, specifically human error in designing this business process compromise related threats, but also the skill shortage and that lead in many cases to configuration errors. So users are no more expert because they have to face with software in any actions they are using security. And this is also connected to the fact that the system is becoming more and more, let's say, interdisciplinary due to the event of business, let's say, big data techniques that allows to use advanced analytics in a different context. This led to the notion of data breaches, which is there since the beginning, but nowadays data is becoming more and more important for the business process as an asset to be protected, as a way to obtain an advantage, even in the business sense. And any leak with this regards will be more and more sensitive than before. The way to obtain data is normally through different applications, and these applications are nowadays everywhere in a miniaturization fashion, using, for instance, microservices, and they are also connected and deployed in a very complex way, making the environment that is no more controllable, complex to deal with. So this service miniaturization is also connected to the fact that services are linked to devices like the IoT device, and the cyber physical system is becoming more and more connected to safety as well, because as part of the system itself, and having a software on top of them and being used by non-skilled person. So we identified,
Marco,
yes.
sorry to interrupt you a moment. Can you try to switch off the camera, because some people are having problem with the sound quality.
Okay, let me try to do it.
So let's try without video.
Sorry for that. I hope that this will be more stable now. So as I mentioned, we identified the list of the key takeaways and how they impact different domains. And then we start making this set of threat and this threat landscape evolving, since this is a continuous analysis that we are dealing with. And this connected with gaps and challenges, and we identify them gaps and challenges that are connected to these threats, and the research actions and countermeasures that are needed in order to cope with gap and challenges. Let's start with the evolving threats. So starting from the initial threat landscape, we identified COVID-related threats and how COVID impact the threats in making them more severe and exacerbating some of them. Here I'm just listing a few of them that we identified for data and IoT devices, like the conversational eavesdropping during COVID pandemic, or the leak of sharing due to hostile home network, for instance, that we experimentally evaluated in different contexts while doing the pandemic, for instance, in case of remote teleconferencing systems. So having this set of threats, we can, let's say, analyze gaps connected to them. So identifying specific threats, then the related gaps could be identified as well. We list the gaps connected to specific threats for a specific domain of interest, and then we analyze them, leading to a set, let's say, of key gap and challenge analysis. But prior to that, we divided the different gaps that we identified into gaps related to specific domain, but also gaps related to the pandemic era, so the evolution of gaps connected to COVID-19, and the cross-cutting gap. So how gap can be cross-cutting, meaning impacting more than one domain. After this analysis, we, as mentioned, we came out with a list of key takeaways, like in case of threats, and more specifically, we identify a list of gaps for each of the domain, and these are the key takeaways that is kind of extract out of the analysis. So we envision gaps in terms of the extension of the attack surface due to the different technologies in place. COVID-19 was an amplifier of threats and attacks. So we saw an amplification in terms of spam and ransomware adoption, for instance. Then security management is a kind of gap in this scenario where the managing security in this very complex architecture is becoming more problematic than before. And then we have to cope with interoperable data protection in a context where we have hybrid systems working together, exchanging data, and then the protection of data is becoming even more complex. So we have to cope with the gap. And one of the gaps that is connected to data is the data trustworthiness. Applications are becoming more and more connected to data in terms of quality of data. It is becoming a strong requirement nowadays. And the trustworthiness of data itself is a very strong requirement, also connected to the fact that data is normally used to train a machine learning or artificial intelligence that is becoming a target and for attacks, but also for a number of threats that we identified. So there is a clear gap in analyzing and verifying non-functional properties of machine learning or artificial intelligence models, for instance, connected to safety or fairness in some cases. Then gap in handling complexity. This is quite a normal gap, but in the current scenarios where we have orchestration in place with different services that are spread in a distributed environment, this complexity is even more challenging to cope with. And also the vulnerability surface is becoming more and more large, and this complexity is also a gap to cope with. Then we have the normal long-standing issues, like the software issues, that is more and more complex due to the fact that we have software everywhere. We also analyze the set of gaps that are connected to humans, like human behavior, skill shortage, misconfiguration, the lack of professionals' capabilities to handle with specific security issues in specific domains, and limited knowledge in order to cope with issues in the complex environment. There is also a lack of standard, even if we have a lot of standard adoption, especially in interoperability in cloud and in transparency of the SLAs, they are not adopted right now. And one gap that is connected to the COVID-19 is quite interesting in my understanding, at least, is that while you react you do some kind of fast reaction to some unpredictable event like the COVID, with adoption of new technologies, then you have to face with training and education that is not there while you started the adoption of new technologies, and this will bring to the careful adoption of new technologies, even if you need to fast react to issues. Then having, let's say, identified different gaps, in order to cope with the gap, we start identification of research actions and countermeasures connected to them. This is an ongoing process. So after having gaps and challenges, we start the analysis of countermeasures and research actions with the same approach, divided them into the 6 domains and analyzing them independently, and then merging at the end with the key takeaways on the research action and countermeasures. So from the methodology point of view, after the identification of gaps, we focus on specific gaps, and we identify research actions to cope with the gaps, like in this case, machine learning and assurance technique for device trustworthiness and training, poisoning detection, and prevention connected to gap on data trustworthiness, for instance. And countermeasure to that, like adversarial learning, ensemble learning, behavioral analysis, and assurance technique in general. So to conclude, we identify threats in a threat landscape, which is a live document. Connected to each of these threats, we identified gaps and challenges to cope with threats, and research actions and countermeasure to cope with gaps and challenges in order to mitigate them. But since this is a live document, as soon as we have new threats, we may have new gaps and challenges, and we may have to cope with new research actions and directions and countermeasure to cope with different threats. So thank you very much.
Thank you very much, Marco. Is there any questions? So please write them in the live chat or question or answer section. But thank you, very interesting. Let's wait if somebody has a question for you, Marco. I mean, I can start myself with the question. Is already available like this document, like for general audience?
Yes. This is let's say a good question, so to speak, because this is normally useful for generic audience also, not just for technical people. And we have them in a different web pages in HTML version, in a condensed way, let's say simplified way, and you can also navigate through them easily. And if you want to go to a very technical, let's say, discussion, we have a link in each of the gap, for instance, for a more deep analysis, more technically oriented analysis. But the document that we have in our web pages, also in the Concordia ones, they are perfectly tailored for generic audience in order to be understandable, even if you are not a specific in the specific fields of security or cybersecurity in general. But we also have a very technical document attached to them.
Perfect. So people can find it on the Concordia website, right?
Yes, exactly.
Okay, perfect. So let me check if there is any question. Yes, so they're asking for the link. If you can put the link in the chat on Team, or you can send it here like on our chat, and I will share it with Team.
I will collect the links and then put in the chat.
Perfect. Thank you very much.
You're welcome.
Okay.
And then if you want to contribute, we have the tool, and then you can download the threat landscape, and you can contribute in proposing modifications, and that we will take care of analyzing your proposal, and we can start a discussion and make the threat landscape, let's say, changing. Also, thanks to the contribution of generic audience, so to speak.
Great. Okay, I don't see any other question. So again, thank you very much, Marco. And we will start again like in less than 10 minutes for the panel bridging the gap between next generation cybersecurity, cloud edge system, and machine learning artificial intelligence. So see you in a few minutes.
Thank you.
Bye-bye.
Thank you.
Okay,
Can you hear me?
perfect. Yes, we can hear you. Welcome back. So we're going to start with the panel, as I was saying before, bridging the gap between next generation cybersecurity, cloud edge system, machine learning, artificial intelligence. And the moderator will be Professor Damiani. So the floor is yours, please.
Thank you very much. Thank you, Ken. It was really a pleasure for me to summon this panel also for the, the participants, the panelists. You will see that each of them will bring a different and interesting angle. But I just want to make a very, very short introduction. We are increasingly moving from a traditional world of traditional services and applications, cloud hosted or not, on premises, to a world in which we have substantial pipelines in which the computations are distributed and they are distributed on devices, they are distributed at the edge of the network, they are distributed in the cloud, they are distributed in, let's say, always a diverse fashion. And we have a number of highly diverse implementation for the same functionalities. And sometimes hardware is doing everything, and in other cases, we have more distributed implementation. So security has to face this evolution, has to face this big change that we are seeing. So I think that discussion, it will require more and more transdisciplinary and interdisciplinary collaboration among the different type of areas in which each of us is working. So the security expertise is more and more an horizontal expertise across architectures, across competencies, and even it has to remember why the pipelines are set up. So what are the non-functional and functional properties that the final customer, the final user will want to see from our application. So the idea with this panel is to bring together people who have both a deep knowledge of an area and also, let's say, a general knowledge and understanding of all the policy, all the framework type of problems that this type of scenario arises. So, of course, I will now let them introduce themselves, basically, but I think that I can very quickly say something about each. We have Ioannis Agrafiotis, Corina Pascu, Valeria Tomaselli, and Claudio Ardagna. So each of them will tell you why they are on this panel, or what they can contribute in the self-introduction at the beginning. But I can tell you that collectively, they are a dream team of panelists. So I don't want now my voice to superimpose. So it will work like this. I will let them speak for a round of self-introductions in which they are very welcome to say something about themselves, but also say something about their interest in these new scenarios that I've tried to describe, or to at least to evoke. And then I have a few questions for them, a couple of questions. So after the first round, I will ask a couple of questions that they will be able to answer. And at the end of this second round, we will also have the opportunity to interact with our panelists with other questions and other remarks. So without further ado, if the panelists are ready, I see some of them smiling, so that means that they are ready. Very good. So if our panelists are ready, I think we can start. I think we can follow if you don't mind, we can follow the order that I mentioned. So the first, I would like to have Ioannis start, then Corina, then Valeria, and finally Claudio for this first round of introduction. So Ioannis, the floor is yours. Thank you very much for accepting our invitation to be on this panel.
Thank you very much, Ernesto. It's a great pleasure to be here on this panel. Indeed, it's a very interesting topic, the one that you mentioned about the cloud edge computing and machine learning. My name is Ioannis Agrafiotis, and I work for the European Union Agency in Cybersecurity, also known as ENISA. Over the last year, I have been involved heavily in a project that has to do with machine learning. I have also prepared a small presentation for this project. I'm not sure, Ernesto, if you'd like me to.
Yeah, why not?
Perfect.
You're very welcome to show a few slides supporting your self-introduction, of course.
Okay, yeah. Just like a very, very small presentation on this topic. I'm not sure if you can see the slides.
Yeah, we can.
Excellent. Right, just go to the beginning. NISA have been doing a threat landscape for the last 5-6 years, and last year it was a special year for us because we decided for the first time to do a threat landscape for the artificial intelligence domain. Therefore, we created an ad hoc working group comprising experts, and we had the great pleasure to have Ernesto as well in our working group to help us with this report. So we created an ad hoc working group comprising experts in artificial intelligence from a broad range of backgrounds, and we produced a report where basically we try to describe what are the assets of artificial intelligence and the systems that actually comprise artificial intelligence components, and then based on the assets we try to figure out what are the possible threats that may encounter such systems. This year we decided to be a little bit more specific about artificial intelligence, and we decided to focus on machine learning. And we are designing our project where we're trying to secure machine learning, and the idea is to focus on the security controls that we need to protect machine learning systems in particular. So what the project is trying to do, we have tried to conduct a systematic literature review of all the different machine learning techniques that exist out there. Based on the literature review, we would like to create a taxonomy of the functionality of machine learning systems. And then on the taxonomy, we try to map specific threats to that part of functionality that we have seen in the taxonomy. In order to identify threats in machine learning, we of course review peer-reviewed journals and any white reports that international organizations of STEAM have published so far. Once we finish the taxonomy with the with the threats, then we try to identify the security controls that we need in order to mitigate or prevent these threats to occur in machine learning systems. Again, we rely on mainstream controls such as NIST, for example, and ISO 27001, but also we do a literature review on papers that provide threats for machine learning, and also they provide some kind of mitigation or prevention techniques. The whole idea is to identify gaps in the current cybersecurity practices for machine learning, and we're interested to find out if the mainstream controls that we use at the moment are sufficient to protect machine learning systems, or we need to invest in identifying further and novel security controls. The final report is going to be ready for validation and for publication in November 2021. So briefly to talk a little bit about the taxonomy that we've created, we have all the usual suspects that you expect there in terms of functionality for machine learning systems. We consider the data type, the data processing, the data requirements based on what type of algorithm we have, if it is a supervised or an unsupervised algorithm, how the algorithms are training and optimizing their different functions, and then the business application. We have decided to add a couple of more functionalities to the algorithm because we think they are important. The first one is explainability. So whether the algorithm is easy to explain and the results of the algorithm are easy to explain to lay users. And the other one is confidence. This had to do with how confident, it doesn't have to do with the accuracy that you usually have for an algorithm, but it has to do with whether the system that provides this accuracy thinks it is confident enough to provide the result. It has to do more with the Bayesian type style of networks. So this is the overall taxonomy that we have come up with. You will find there are many different machine learning algorithms and how they're classified in the different functionalities that we have chosen to use. When it comes to the attacks against these algorithms, we have identified again the usual suspects. You have evasioning, poisoning, backdooring, Trojan inference. I'm not going to go into detail, but we have done an extensive literature review on the different types of attacks that we have seen out there, and we have mapped these attacks on the different functionalities in our taxonomy. And then we decided to come up with security controls that may help either prevent or mitigate these attacks from occurring. So the sources, as I said before, for the security controls were NIST and ISO 27001, but also published literature in peer-reviewed journals. So we have identified a range of security controls for all possible threats. Just a few examples for to give you an idea of what we're talking about is to add adversarial examples to training data sets, which is not a mainstream control that we see, apply role-based access control systems, which is something that we do see in many standards, and also to conduct risk assessments before applying machine learning systems. We have more than 25 different controls identified. Most of them are unconventional controls that we don't see in current standards, and we have identified the need to raise awareness in the community that these controls may need to be applied when you have a machine learning system. We also found something that was very interesting, that when you try to implement some of the controls that are specific for machine learning systems, you may end up causing conflicts with other desirable properties of machine learning. And there we have another project, and Ernesto is part of this project, in order to identify these conflicts in controls and to understand how we could actually decide which control will benefit our organization. And to give you an example, when you try to train with adversarial examples, so you add adversarial examples in your training data set, then you may have some problems with the accuracy of the system. So this is a small presentation of my background and the work that we do at ANISA. And if you have any further questions, I'll be happy to take them on later on.
Thank you very much. By the way, now it's Corina's turn. By the way, I basically would like to make amends because I forgot to mention after Claudio, we have another distinguished panelist, which will bring a strong industrial perspective also to our questions and to our panel. This is Alexandru Catalin-Cozoi, who is the Chief Security Strategy at Bitdefender, but he will have the opportunity to introduce himself. So apologies for not having listed the name at the beginning. So I would like now to leave the stand to Corina Pascu. Corina, the floor is yours.
Thank you very much, Ernesto. And hello, everyone. My name is Corina Pascu, and I'm working also for ENISA, but for a different unit, which is called Market Certification and Standardization, which deals with certification and candidate cybersecurity schemes. But also I'm working, I'm part of a team cross unit in ANISA, and this is the team for research and innovation. And as part of this team, we have been working this year on some research teams, and one of them is artificial intelligence, and also transversal aspects, interlinkages with the biotechs or cryptography or 5G or next generation communications. Just to show some slides, maybe that would be helpful. Let me show. I don't know if you can see it. I can make it bigger. Is everyone seeing?
You can see it.
Right now, it's coming up. So my colleague, the previous speaker introduced you to the expert group working on artificial intelligence and the work that's been carried out in the the aspects of artificial intelligence in relation or from the perspective of cybersecurity is twofold. One side is on securing AI. So we need to understand what needs to be secured and to develop the security measures. So this has been presented also by the previous speaker. But the other side is also using AI as a tool to support cybersecurity. So in this respect, we aim to provide advice on the research needs and priorities on artificial intelligence for cybersecurity. Another part of the work that is carried out in the research and innovation team, it's in relation to the emergent challenging and the risk in relation to cybersecurity, which is tackled by a special project carried out in ANISA foresight. That is a perspective. But in relationship to the research. So we look into the areas where we need, the European Union needs to stimulate the research and innovation, and what could be the, so we look into the current cybersecurity research and innovation work currently done, and what else needs to be done, and what are the main research teams, and what are the other technological trends that may have an impact on the security in the cyberspace, like the three teams that I have, the emerging technologies. But in relation to research and innovation needs, which is part of the work that we have done this year, so the approach that we have followed is to look at the from the cybersecurity task, such as prediction of attack, prevention, detection of threat and intrusion, response, planning, and then looking from this starting point on which artificial intelligence, machine learning, or methods can be applied to address this common cybersecurity task. We also acknowledge the double-edged role of technology. So AI can be used to harm, and most of the times it's used in this way, but it can be also used to protect systems. So the uses of AI has been, what we see today is that AI can be used as a power defense mechanism. It can be also used by the cyber threats exploiting AI, and the AI can be subject or object of attacks against their own its own security methodology and the protection mechanism. We also looked, as I said, on the linkages of AI with other emerging technologies like 5G or next communications, crypto, or biotechs, especially in view of COVID-19 pandemics this year. This would be just a few elements. Just I wanted to so just an example, what would be the key cybersecurity problem that we look into and can be solved using machine learning, for instance. So we took, for instance, in the offense, the potential of AI to change the self-propagating cyber capability of malicious code, or it can be used as a cyber weapon, for instance, against critical infrastructures. In the defense area, the AI methods can be used for cyber defense, as I mentioned before, in the attack prevention, detection, and response. It can be also used in the prevention space, for instance, in user authentication, and in detection to detect attack, intrusion, or malware, for instance, and anomaly detection. Also, we addressed the security and safety of machine learning itself. It's been mentioned before, adversarial AI, and it is also the case of data poisoning and model inversion. So when AI or machine learning can be unintentionally reveal secrets. And also the boundaries between offense and defense, which is due to asymmetries in operations. So, and we also came up with areas which AI ML techniques can be well suited for cybersecurity, for this common cybersecurity task, and which ones are not well suited. And just to give you a snapshot of what our work has been about this year. Thank you very much.
Thank you very much, Corina. So I think that we are getting a closer, a better and better understanding from this self-introduction. So it's my pleasure now to invite to take the stand Valeria Tomaselli from ST, which is a company that has led the way in a number of application of AI and architectures, hardware architectures for AI specifically. So looking forward to your talk, and the stand is yours, Valeria.
Okay, thank you for the invitation. I'm sharing a brief presentation I prepared. I work in ST Microelectronics, which is one of the largest semiconductor companies in the world with 46,000 employees. And in particular, I work in the artificial intelligence software and tools organization. First of all, I want to give you a very brief introduction on cyber physical systems, which are composed of three parts, the physical domain, the object domain, and the cyber domain. So the physical domain is the real world where we live. The object domain is composed by all the sensors that interface with the real world, grabbing data from it. So we can consider in this category ambiental sensors, inertial sensors, audio sensors, camera sensors. So all the that sensors that can grab data from the real life. And these sensors can send data to the cyber domain where the data are processed in order to have some actuation. So it is straightforward to think that all the intelligence can be put on the cyber domain, because we usually think that we have unlimited resources on the cloud. And this is why up to now the main stream has been the centralized AI. This means that we have dummy sensors that simply collect data and send them to the cloud for processing. So on one side, we have unlimited resources on the cloud. We can simply update the algorithms, but we have also some drawbacks. In particular, we have a bandwidth problem, especially if we consider the IoT paradigm where billions of sensors will be connected to the cloud. And we have also data privacy issue, because data from the users will be sent to the cloud for processing. And another problem is related to energy consumption. Consider that these data centers are responsible for the 1% of the worldwide energy consumption, and it is a number that will increase in the coming years. So for this reason, we are moving the artificial intelligence near to the sensor at the edge. And we are talking about edge and also deep edge. This because we at ST have ported artificial intelligence directly inside the sensors for a first processing of the data, but we are also implementing artificial intelligence in our microcontrollers. And moreover, you can think also to communicate with the cloud for some higher demanding tasks. And with this scenario, you can save the data, you can protect the data privacy, because the data remain near where they are grabbed. And moreover, you save energy because all these solutions are very low power. And this new paradigm will be a distributed paradigm. And in this slide, it is reported as a drawback, but in reality, it opened the ways for a new paradigm such as federated learning, where the cloud, for example, can aggregate models coming from different sensors, from different devices, and update, create a more robust model that then can be deployed to the sensors. Obviously, this paradigm will open also the way for new attacks, for new cybersecurity risks. Okay, and embedded AI is not only important for ST. It is there is a study according to which by 2030, 2.5 billion of devices will run AI in embedded devices. So in ST, as I already said, we have smart sensors. We have a family of inertial sensors that incorporates a finite state machine and also decision tree for classifying human activity. And at a higher level, we have also artificial intelligence techniques, in particular deep neural networks that can be ported into STM32 microcontrollers. This thanks to our tool STM32 Cube AI, which maps pre-trained neural networks into optimized code for our microcontrollers. And then we have also microprocessor that can run neural networks through TensorFlow Lite engine. So at the moment we are addressing both low and medium range applications, medium complexity applications with our current products. Obviously, for addressing applications having higher requirements, we will need next generation of MCUs, MPUs, embedding hardware accelerators that are designed for accelerating convolutions, so multiply and accumulate operations. The big interest in embedded AI is also confirmed by the TinyML, tiny machine learning community that is increasing year over year. The objective of this community is to have machine learning embedded into the devices with the very low power requirements in the range of a milliwatt, and then enabling some always on use cases in battery operated devices. Thank you.
Okay, I think it's my turn. So share my screen.
Yeah. So I was trying to unmute myself frenetically, but Claudio, the stand is yours. Thank you very much.
Thank you. Thank you, Ernesto, for the invitation. Thank you, Antonio, for the organization. I'm Claudio Ordagna, and I am a professor at the University of Milan. I'm also the director of the Cini National Lab, Italian Lab on Big Data, and I'm also proud to be a Concordian. So let me start from some data. So today, the edge computing is really leading the innovation, and the market, the global market capitalization is predicted to reach $800 billion by 2028. This is driven mostly by IoT and sensors. 30 billion IoT connection and sensor for each person on average is predicted by 2025, and is also driven by 5G. In this context, the delivery model is really changing, and the paradigm of micro data centers are emerging, with a market that is predicted to reach $15 billion by 2025. And in this context, 3 quarters of the data are predicted to be processed and created at the edge by 2025. On top of this, we have artificial intelligence and machine learning that is increasingly deployed at the edge, as we have already heard by my colleague, and trained in the cloud. For sure, we have a lot of new issues, ranging from issues related to the environment that is heterogeneous in nature, with a multitude of resource-constrained devices and with a certain topologies and boundaries. We have issues related to data and model that are in principle untrustworthy, and this could point to the paradigm of zero trust. And we have also issues on the infrastructure. So what we are going to is a scenario where we are moving from Internet of Things, from Internet of Everything, where we have things that collect and possibly analyze some data. We have done a real huge amount of data that are collected and used to reason on, and by increasingly smarter, continuous and collaborative processes that are then provided to people that also become part of the game. In this Internet of Everything, people is just another component of the modern distributed systems. The core of all these new environment are knowledge and data. Data are at the core, and then we have three main dimensions. On one side, we have the analysis of data and machine learning. On the other side, we have the infrastructure, cloud, and the edge services. Finally, we have security and cybersecurity that represent probably the major enabler of this environment. And then in the remaining of this small introduction, I would like to briefly introduce two open challenges that are very relevant in my view. The first one is about secure and robust machine learning. The second one is related to certification of machine learning and artificial intelligence. So two dimensions, one on security and one on verification and assurance. So why machine learning models become the target of many threats and attacks? Because they are at the center, at the core of many autonomous systems, and then the adversary can try to impact and change the decision making of these processes. And basically they can do that by either targeting and poisoning the training data, or by forcing the model to the desired output. So here we need to protect the machine learning model end to end, and not just focus on model poisoning. And then we have also adversarial attacks. So the major threat here are the smart devices. The smart devices are a central part of the environment and of the system, but on the other side, they are often resource constrained, and then for sure less secure than traditional components. And so on top of that, we have also the problem of being able to distinguish in between trustworthy and untrustworthy data and data sources that are really making this problem of securing ML and AI increasingly difficult. So the idea, the open challenge here is to increase the robustness of machine learning, enabling a secure application of machine learning in the modern distributed system, and in the end, increase the resilience of all those processes that drive our life, and in the end, could impact on our safety. And this is just a very quick example took from a project in which we are involved. And basically the idea is to take traditional monolithic approach and try to basically increase their robustness by producing a process based on a collaborative training and a collaborative inference process. The second point I would like to raise very briefly is about artificial intelligence and machine learning assurance. Assurance is the way to verify and monitor the behavior of a specific system, and to provide enough confidence that the system will work in the expected way, independently from faults and attacks. So applied to machine learning and AI, introduce some requirements on the transparency of the machine learning model behavior, introduce requirements again on the collection of trustworthy data that are at the basis of the decision taken by the models, and then finally to continuously guarantee security properties of the whole supply chain. And this whole supply chain mean also the security properties of the machine learning and the artificial intelligence algorithm. This is something that we were not used to until a couple of years ago. And so the idea is to provide a new way of certifying machine learning and artificial intelligence. And this to the aim of verifying new properties, transparency, performance, reliability, safety, and fairness that have as a target the specific machine learning model. And this, pointing to the the panelists that talked before me, to the goal of providing solution to adapting the behavior of the machine learning models dependently on the status, on the environment, and on the monitoring of the non-functional. So just a quick conclusion, machine learning is a key enabler of modern business, and the idea that security, trustworthiness, and transparency of machine learning and AI must unleash the full potential of modern distributed systems. So on one side, security of machine learning, and on the other side, certification and assurance on the behavior of machine learning. Thank you very much.
Sorry. Thank you very much, Claudio. This time I unmuted myself on time. So I think we are moving on with Katalin. Again, sorry for not mentioning you in the first round, but last but not least, definitely, because I'm very interested in the point of view that you will bring.
Yes, don't worry about it, Ernesto. Thank you very much for the
stand is yours.
Thank you very much for the invitation. I hope you guys can hear me, right?
We can.
Okay, I don't have any slides for today, so I'll speak freely. My name is Alexandru Cătălin Coșoi. I work for Bitdefender, which is a cybersecurity company active in the consumer business and IoT space. And the IoT space is very interesting. I'm gonna go to that in a second. And currently, the team I'm active in is a smaller team. It's called Investigations and Forensics Unit. And basically, we are tasked into helping law enforcement with their ongoing investigations, but not only necessarily technical expertise, also providing maybe tools or technologies that embed machine learning or other sort of technologies for their help. Examples of recent technologies that we provided to law enforcement are nudity detection, which is very helpful into going through large amounts of photographs and extracting the ones that are interested for the child pornography departments. Very useful in order for them to rapidly sort out the images that are required for the case. Another project that is being currently under development is the darknet author attribution. Basically, these are machine models that are looking at the way people are talking on the darknet and also the way they are talking on the clearnet in various hacking forums or other sorts of forums. And the idea would be to pinpoint the fake persona from the darknet to the clearnet persona and to investigating who the author is. And also recently, we are also having a project on blockchain analytics that also involves machine learning because it helps law enforcement easily dismissing particular Bitcoin or other cryptocurrency wallets that are not necessarily relevant for the investigation. So I started working with Bitdefender back in 2004, and it's the first and only job. So basically, I've been acting with the security industry my entire professional career. Next year, I'll be turning 18 years old in Bitdefender, and actually started working directly on machine learning algorithms, especially on anti-spam and anti-phishing filtering. And two of the technologies that I've been working on have actually been patented in 2006 and 2008. And now I'm not that more active on the machine learning space, but I can tell you that Bitdefender has a dedicated machine learning department. The reason for that is that while 2 decades ago, cybersecurity industry was very easy to go through, as in there were like 1 or 2 viruses discovered per month, for instance. So easily to actually tackle manually. Nowadays, we're talking about a few 100,000 per day, so tens of thousands per hour. So scaling that fight on human power, it's practically impossible. So machine learning has been our bread and butter in order to tackle the magnitude of the situation. And not only endpoint, I'm talking about also about the movement to the cloud. So more sensors have to be deployed in Google, in Amazon, in AWS, and so on. So basically, you need machine learning models to fight cybercrime these days. You cannot do it with the old methods. And we're doing a pretty good job. We've been #1 in independent comparative tests for the past 5 years, I guess. and more than 30% of the cybersecurity products out there actually are using Bitdefender technology under the hood. So that'll be it from my side as an introduction. Thank you.
Thank you very much for staying in the time. We had in a sense, the introductions were very interesting, so I didn't want to cut them. On the other hand, we are well into the panel time. So in order to be able to also ask the questions, let me condense them. I had basically three topics that emerged from your presentations that can be distillated into a question, which includes, well, we saw what is basically the interest, but what, in your opinion, are the critical areas? What are the gaps? Can you highlight from your own presentation or from what you heard from the others, what do you think would be the critical aspects to secure these pipelines that we are going to face now? Secondly, those pipelines include the devices and include the devices that have limited computational capabilities. Is this going to be the weak point? It is something we all hear, but how hard it will be to incorporate these devices in the pipelines in a secure way? Thirdly, do you expect these pipelines to be or to need certification of some sort? Do you expect those testing and being able to certify security properties to become also interesting from the commercial point of view in the future? So I've just thrown this on the table. Feel free to address one or more of these sub-questions. I would give you 2 minutes each. And I want to, please, let's follow the same order as before. And you are very welcome to start speaking without waiting for me, so we will save the time of the connection. So let us start from Ioannis again. You heard what I said. What do you want to add to your point of view based on these questions?
Thank you, Ernesto. All three are very interesting questions, and all the presentations from the panelists were extremely useful for me, and I got a lot of interesting details on the edge cloud computing and certification and on machine learning as well. As I said in my presentation, we focus mainly at ENISA on securing machine learning, and what we see there is that there is a conflict between different security controls that we need to do. In certain cases, I imagine that this can only be a conflict or a compromise that we need to do when we talk about different sensors deployed in parts of the network, and when we talk about edge computing as well, especially when it comes to those sensors that have lower energy requirements, for example. And definitely what it is mind-blowing for me would be the issue of certification machine learning. So how do we first approach the problem? What do we mean by fair? We don't even have a fair society. So how do we approach the problem of fairness in a mathematical way that we can actually prove? How do we ensure throughout the life cycle of a product for machine learning, for example, that the integrity of the data? How do we ensure that we can have a fair or an accurate algorithm when there are cases that we don't even know how to explain the results of the algorithm? So these are all very, very difficult questions that I'm not sure how we'll be able to tackle in such a short time. Maybe one case when it comes to certification would be to come up with different counterexamples and then collect these counterexamples based on the attacks that we see happening, and then we train the system, and then we try to actually test the system with these counterexamples and see how the system will react. And this will give you some sort of assurance, not a definitive one, that the system, okay, it may be trained properly. So I'm not doing fair to answering your questions, I'm afraid. I have more questions that you actually asked me to answer. But I think definitely that although we are providing solutions to the usability of systems, to the friendliness, the user friendliness of the systems, and to actually expedite the results and the answers of these systems with edge computing, we may be introducing certain problems when it comes to security, because we're bounded by the hardware of the sensors and the amount of energy they can carry with the type of processing that they can do, and also the machine learning and the types of algorithms that we use for machine learning. And it's going to be very, very difficult, I think, to come up with a decent certification scheme in the near future.
Thank you, Ioannis. Corina?
Yes, sorry, I will keep my video turned off for reasons, for bandwidth reasons. But just to give you some things that I think are very important on what more can be done with respect to artificial intelligence and ML, machine learning. So one issue that it's very important is to develop explainable machine learning algorithms, including for the deep learning models. And at the end, explainability is a system issue. Then we need to work on integrating multidisciplinary perspectives, which include the social, technical, economics, for instance, of AI applied to cybersecurity that we haven't heard much, but also regulatory, cultural, or also cognitive issues are very important issues. Understand the motivations and the intents. This may offer clues into how AI may be used for a particular offensive task, something we're actually doing for the 5G, for instance, looking at the motivations of the attackers and also the means. Also, observational research in extracting value from games and simulation can be a starting point for gathering insight. These game theory techniques, rather than the explainability or data availability, would be a critical issues here. And also penetration testing, so to find security vulnerabilities that an attacker could exploit, and then trying to understand what the attacker will do. So this could be addressed with artificial intelligence beyond machine learning as well. And just one geopolitical issue that can be raised, that the impact of AI ML on cybersecurity will vary from the perspective of different countries, because we have different risk and tolerance levels and data access, and the separation between the companies and the government and the industry, and also the gap, closing the gap on shortage of cybersecurity professionals, so the issue of skills. In addition to that, just to answer some of your questions, are food for thought. Some examples of gaps and challenges. So when the new edge computing meets AI and IoT, so to speak, the worlds. So there's benefits for IoT from the use of edge computing. So in the case of IoT, it can provide, edge computing can provide performance benefits such as real-time computation and reduction of dependence on network connectivity into the cloud. However, the interconnecting technology represents a larger attack surface with respect to security. And the edge is harder to secure, and security relies very much, when we speak about IoT, from the IoT developers. And also with respect to the risk of those attacks in the new edge computing world. So the emergent, as I said, the edge computing is bringing this larger attack surface. We have witnessed the most notable attack in this respect was the Mirai virus in 2016. And the variations of Mirai are believed to have infected 400 million IoT devices only in 2017. So, and this is increasing. Finally, last but not the least, some of the challenges in certifying. Indeed, certification, it can be a solution, and it should be the result of a consensus. The robustness of some components of AI solutions against the attacks can be assessed in the process of certification in the framework of existing candidate schemes that ENISA has proposed. In this respect, we have the EUCC common criteria looking into certification of ICT products, And also we have a second candidate scheme, European scheme, looking into the certification of cloud services, EO cloud services. For some specific threats, like threats trying to manipulate for data poisoning, basically, or adversarial examples or model flow, we may need a dedicated AI certification scheme in addition to this current candidate scheme. Recently, we have seen some national efforts in AI certification. For instance, the French AI 2021 LNE scheme. So that would be my insights. Hopefully it helps.
From my side, with respect to the first question, the main challenges, the main cybersecurity challenges I see are on one side related to the connection of different devices, so it is independent from AI. On the other side, they are related to AI attacks and the risks of AI subsystems. For the first category, distributed systems, obviously the state-of-the-art security techniques and best practices can be used. A big issue could be the software vulnerabilities, because it is very, very difficult to write software that is protected by any kind of attacks. And on the other side, we have so the cybersecurity challenges related to AI. As already the other panelists have said, there are the so-called adversarial examples that are very small perturbations of the input of the network that causes a misclassification of the network that modify the network outcome. This problem could be mitigated using adversarial training, so including the adversarial examples in the training phase, but obviously the network will be robust to a specific subset of attacks, so many more attacks could arise. Another challenge I see is the protection of the confidentiality of the network in the embedded systems. This confidentiality is very important because we need to maintain the intellectual property that is inside the network configuration. And moreover, if we don't have the confidentiality of the network, it can be subjected to adversarial attacks and fault injection. Obviously, in our solutions, we have security mechanism in place in our system on chips, in ASICs, in microcontrollers, and so on. But we need to keep the confidentiality of the network. For the second question, I think that, okay, the limited resources can be a problem in the distributed environment, but this risk can be mitigated by a proper design of the embedded system and of the machine learning and artificial intelligence solution. For example, our tool STM32Cube AI, which maps neural networks into microcontrollers, estimates the total amount of memory that is required for running the network. And we don't allow to have dynamic allocation during inference time. So we know the total amount of memory at the beginning when we import the network. So we don't have this kind of congestion problem if you well design the system. Moreover, there are many techniques for reducing both computation and memory requirements. So we can compress the network, we can quantize the network, or even deeply quantize the network or parts of it using less than 8 bits. One issue I can see is for online training, because a new research topic is training directly on the device. In this case, we need to fix an upper bound on the memory that we need for training, and also on the time we need for obtain a stable solution. But this is an open point, a research topic is still a challenge.
Okay, it's my turn. I will try to be very concise since we are running out of time, and then also most of the comments that I had in mind was mentioned already by my colleagues. So regarding the first question about the gaps, I see three main issues. The first is around data protection, because now we need to protect data from threats to privacy and confidentiality of sensors. And sensors are by nature very resource constrained, and then loss of information, interception of sensitive data, unauthorized access are more probable than ever. On the other side, we have an unprecedented capability on analyzing and inferring information on data, and this could threaten the personal sphere of the user. So we need to provide solutions that balance between the effectiveness of ML and AI and the protection of the end user. Second comment about data trustworthiness. Usually we see approaches assuming data to be trustworthy, at least by their volume, since we have a lot of data, or on the basis of provider reputation. In this scenario, we need to make a step further, mostly due to the sensor we have in our systems, and assume zero trust or no trust, and implement a continuous verification of both data trustworthiness and also data source trustworthiness and validity. And this could assurance techniques and monitoring and validation techniques can help in identifying potential problems. Last gap is about the big data analytics and the machine learning model. I already mentioned about the robustness of the machine learning models, and it is very important to increase the robustness of the models we are using in our autonomous systems. Last but not least, COVID-19 changed our boundaries, and then our data protection, data management, and analytics must be cross-border. So consider borders that are not more known a priori and can cross many different boundaries. And here we need some sort of end-to-end verification that verify the trustworthiness, robustness, and security of data sources, network components, sensor, and so on and so forth. What mentioned by Ernesto about the risk of self-denial of service attacks, I think this is really a gap. So we are used to a security solution that have a principle, whatever it takes, don't care about the overhead, the impact of the system, but just try to evaluate security. This is not anymore possible today, because this would easily turn out in a denial of service attack. So we need to design and develop new security solutions that are less focused on the specific component, but rather on the behavior of the whole system. And regarding the last question about certification, I agree with Ioannis, and we need to make a new step in certification techniques. We had the first step from service-based certification to cloud system certification. We need to go beyond this, and we need to prepare certification for an environment that has no fixed topology, no clear boundaries, are built on non-deterministic behavior, and we have many challenges that have been already mentioned by Ioannis, starting from the definition and the formal definition of the properties we want to to certify the modeling of the target of the certification, that is not anymore the sum of its components, and finally the definition of new statistical approaches to the certification of machine learning model. All these again baked with trustworthy data and evidence on the system build.
Yes, I'm last. Do I still have a minute?
You can. We are looking forward to your answers. So please go ahead.
Okay. So I'll share a bit of my my perspective from the security industry actually activating in cybersecurity. One of the gaps that we're facing is actually the lack of sensors. Let me give an example. So back in 2013, so I guess that would be 8 years ago, we launched a security product called Bitdefender Box. So Bitdefender Box was a security product addressed to IoT devices. It was coming in two flavors. One of them, it was a hardware appliance, like a router that you had in your house, and all your IoT devices would connect through that router to the internet. So basically, we're sitting on the traffic and analyzing what the IoT devices were doing. Or the other option would be as a software appliance, which comes embedded in other router manufacturers, because as a security company, it was very hard to go actually in the hardware space. At that time, people were saying there aren't any IoT threats, right? There were just maybe a couple of early Mirais, a few other IoT vulnerabilities, but nobody was actually looking at the IoT space from the security perspective. And also back then, the IoT community was launch now, think about security later. So security was definitely not in their mind. And once we had a sensor in there, we were actually able to see how many threats were targeting these devices, how many were coming with default root passwords, how many were very easily to hack or reuse or embed in a botnet. So the lack of sensors, to extrapolate from that, is still a problem, because if you give to a machine learning algorithm training data that only sees part of the problem and not all the other places that it could actually gather intelligence, and based on those features can actually make an informed decision, it will only see just part of the problem. So that would be one gap. And the other gap would be once you have enough data and your machine learning algorithms can make very good decisions, it will also solve a current problem, which is alert fatigue. Now, the analysts that are getting information from machine learning algorithms, notifying them about potential breaches or potential alerts, so far, there's so many alerts that they're wearing down very easily. So this is what we call alert fatigue. As for the certifications, Corina mentioned a few. For instance, in the cybersecurity industry, what happened was that a few independent test organizations arose in time, but they opened the door to the certification methodology, and all the private sectors had at least a person in that group, in the community, trying to provide feedback and to create a common sense among all the players. So when you join that testing methodology, you have a person that already verified the methodology. You agree with everything in there, so you're obviously going to agree with the outcome of the certification. So my suggestion would be to open a new community which brings together both private sector and academia, and that could actually come up with a very interesting plan into offering certifications to machine learning algorithms. That's it. Thank you. And Ernesto, if you're talking, you're on mute.
Okay, I think we lost Ernesto, but I think was anyway like the the final round of question and replies from the panel. So I would say, I mean, what I can do, I would thank on behalf of Ernesto for your participation in this panel. It was, I mean, as an attendee, it was a very interesting one. Thank you very much to all of you. And just let me check quickly if there is any question from the audience, but I didn't see any so far. So I would just close it here, but the audience can always like contact you through the team platform in order like to if they have specific question. And otherwise, thank you very much for everything, and see you at 14 hours for the next session and the next panel. Thank you very much. Have a nice lunch. Enjoy your lunch.
Thank you.
Thank you.
Thank you. Bye.
Thank
Thank
you
you very
very
much.
much.
Bye.
Bye.
Hello, good afternoon. Hello, Iro. Hello, Antonio. Yeah, it's Roberto. Can you hear me well? I cannot hear you. Just checking my audio. I cannot hear you, Iro. I don't know whether it's only my problem or...
Hello.
Hello, Ninetta. Nice
How
to...
are you?
A bit sick, but okay. You?
Oh my God, I hope nothing serious.
Well, let's see. Let's see. I don't know. No, nothing serious anyway. Just
Okay. Did you do you conducted the COVID test?
today I'm gonna go this afternoon. So
Hello, guys.
Be careful.
Hi, just to let you know, you're already on air. Eh?
Ah, we are already on air?
Yeah, exactly.
Okay.
So we're just waiting like a couple of minutes, and then we will start with the panel. Hero, we cannot hear you. You are muted, actually. No.
Testing.
I heard something. No. Okay, she will try to join soon.
Hello, can you hear me now?
Yes, perfectly. I mean, a bit low, but we can hear you.
It's okay. I can increase the. Can you hear me any better now?
Yes.
Great. Great.
Okay, let's. I think you're just missing one person.
Philip, I think, is not in yet.
Okay, so let's wait. I mean, it's early. We still have 5 minutes, and then you can start here.
Yep. Just one more test. Can somebody speak so I can see if this will.
Hello.
Yes.
Yes. Can you hear me?
again?
Yes.
Okay, great. Great. No echo is coming in, right? Because now I have two devices, one in my ear and one in the computer. So there's no echo.
Nope.
Great. Thank you.
Okay. I think everybody's online now. Perfect. So
Maybe a short
we'll,
test for the sound for Philippe so that we don't have any problems later.
yeah, Philippe, can you hear us?
Yes, hi. Yes.
Hi.
Perfect.
Hi.
Great. So, welcome back to everybody. I hope you enjoyed your lunch. So, we are starting this afternoon with another panel. This time, the topic is cybersecurity product certification, insight, challenges, and way forward. So, for this panel, I will give like the floor directly to Iro. It's our certification and standardization lead. And yep, the floor is yours. Thank you very much.
Thank you, Antonio. Hello, everybody. Good afternoon. I really do hope you got to enjoy your lunch break and also take advantage of the lobby area and converse with other people. Although it's a virtual event, I hope you managed to network a little bit. I would like to welcome you on this panel regarding cybersecurity product certification. We're going to talk about a little bit to have the insights of four very good colleagues from the industry and the academia, and they are going to discuss and give us their opinions regarding the insight, challenges, and ways forward in this area. So I will not keep you much longer. So the first speaker would be Roberto. Roberto is a senior policy manager at the European Cybersecurity Organization, and he coordinates activities of working groups looking at certification. So he's going to provide us some feedback from that perspective in policy and developments that are being at this point in cybersecurity certification. Roberto, the floor is yours. Thank you very much.
Thank you so much, Hiro, for the kind introduction. Good afternoon, everyone. So it's a pleasure to be here. I'll try to share my screen, just a couple of slides, merely to facilitate a little bit the discussion. I hope that you can see my screen at the moment. So what I'm going to present is just some activities that we are doing in an EXO working group. One, indeed, dealing with standardization, certification, supply chain management. Just a quick note, I think that most of you know what is EXO, the European Cybersecurity Organization, but just as a quick recap, so EXO was the counterpart of the European Commission for implementing the public-private partnership in cybersecurity. And still, we continue the discussion with the European Commission, in particular, with respect to the European Cybersecurity Competence Center and all the different activities spanning also linked to the industrial policy. So the goal is overall to coordinate the development of the European cybersecurity ecosystem, supporting all the activities, the work program of the European Commission, that also the one for 2022 was just published yesterday, with all the different activities, and in particular also to contribute to the advancement of European digital sovereignty and strategic autonomy. So the ultimate objective it's clearly to achieve cyber resilient digital Europe, and I would say that one key aspect is the establishment of trusted and resilient supply chain. So cybersecurity certification could be one of the ways, for instance, to address this issue linked to ensure that we can rely on a trusted and resilient supply chain. Why? Because we could have on one hand, we it could help fostering a spirit to increase the cybersecurity posture of different organizations on one hand. On the other hand, also, this could be a way to have a third party assessing also certain products. I'll just go a little bit more in detail with respect to the activities that we do in the EXO Working Group 1, and then link to the question that Hiro has indicated at the beginning with respect to cybersecurity certification. So our objective is to facilitate, to support the rollout of the future cybersecurity certification schemes. And we know at the moment that there are like 3 requests that have been done by the European Commission. One, it's about the UCC, the European-based common criteria cybersecurity certification, about the cloud services, and then also there is a last one linked to the 5G. But also it is linked to the activities on standardization, because one of the key aspects is also to rely on standards that are agreed by community and then are shared, and then can provide, like a way to rely on something that is agreed and solid. And clearly, also, we focus on the different legislative recommendations. So if you look at the Cybersecurity Act, so it has clearly also interlinks with the certification, is interlinks also with all other horizontal legislation. If you look at radio equipment directives, for instance, but also the NIS revision and so on, when there is also a link with respect to the certification. So overall, there is quite a lot to do in Europe, and then so EXO poses itself not to work on cybersecurity certification schemes or standards, but to interlink with the different communities and work more on the approaches and methodologies. So with respect to that, we have 2 specific strands. One is about connected components, another one about systems. If you look at the activities that we have done so far, and then I think that the scope of the panel today is to focus on the ICT products. So I would like to just to mention a couple of things that are linked in particular to a document that is the EXO composition, product composition document that we published last year, November 2020, that it provides some specific guidelines to facilitate the certification, reusing evidence on components that will be integrated into products. So nowadays we are also, if you look, for instance, at the Cybersecurity Act, and then what is indicated with respect to the, on one hand, the management of the vulnerabilities in patches, and also on the monitoring of the compliance. So clearly now the challenge stands with respect to the operational aspects, and these are issues that we are discussing nowadays in a follow-up version. So moving from specific guidelines to understanding the risk, and then manage how the risk could be managed, but also linked with respect to all the operational challenges that we have to deal with. At the same time, so we have we have approved a new document related to system certification and then consideration. What I would like to stress here is that EXO is working in cooperation with different stakeholders. So clearly, we are a member of the stakeholder cybersecurity group that is created under the Cybersecurity Act. And we have also a collaboration with Sensele and Dazzi, with whom we have a memorandum of understanding, and clearly discussing with the Commission and ENISA. What is important, and for me the key message here is that all the activities that we are doing are meant to be in collaboration with all the different stakeholders, because we need to have, on one hand, a close collaboration between the manufacturers, the evaluators, and the end user that needs to be part and integrated into the same dialogue. But also, at the same time, it's important to have a dialogue with all the different institutions. Why? Because cybersecurity certification has clear impact also for what concerns the market. So it's very close to the market. That is an important instrument that we need to take in consideration. For what we have seen so far, so there is clearly a strong interest into certification. So we will look forward for the first clearly implementing act of the UCC scheme that is currently under preparation, and that will set, let's say, the ground for what will happen in after the first European cybersecurity certification schemes will be available. From standardization, so there is an important consideration in EXO. We have a document that it needs to be updated now, but clearly because we have new standards coming in particular when we look at IoT, there is an interest also with respect to artificial intelligence and also new upcoming standards in addressing all the different aspects. So clearly, so we have this state-of-the-art syllabus that it needs to be gathers together all the different standards, and it is important to ensure that there is a clear synchronization between what it needs to be, let's say, the new cybersecurity certification schemes, but also the standards that needs to be available in support on definition of requirements, but also evaluation and so on. As I mentioned before, is one key aspect to rely on also on standards. And I think that I will close here and then also leave some time for questions later. Thank you very much.
Thank you very much, Roberto. Thank you very much for this very interesting presentation and the efforts that are being implemented by EXO on the subject of certification. I really like the fact that you mentioned that certification and standardization are actually interlinked. The one really needs the other in order to be able to function correctly and achieve their goals. We are going. I think we're going to gather all the questions at the end. So for the time being, I will then pass the floor to Ninetta. Since we are taking, Roberto already mentioned that there is a link between also supply chain. So Ninetta is going to provide us with this link between cybersecurity certification and the supply chain and how it is affected. Just a few words on Ninetta. A lot of people may already know her. She's a cybersecurity professor with experience that is over 25 years. She has been active in many different positions, amongst which was as a policy officer in the European Commission for the DG Connect H1 unit. And she is also involved in many European projects, and she's going to present that from that point of view. Thank you very much, Ninetta. Yours. We can see your desktop there, but now we can see the...
Hello, thank you very much for this invitation. Can you hear me now? Okay, great. So as we know, the Cybersecurity Act actually is covering certification related to ICT products, services, and processes. So the question here is, what do you mean by certifying the supply chain services? Now, about supply chain services, we see this word of supply chains in different legislation and initiatives, like the NIS, the proposal for 2.0. The proposal mentions the need to address the security of supply chains and supplier relationships. We also saw in the liability, of course, for defective products, and in the EU Security Union strategy that mentions the need for strategic autonomy and resilience for our supply chains. So the question is, though, what is a supply chain service? I guess in all sectors, whether it's in health, in transport, in maritime, in government, all services these days are actually supply chain services. Why? Because they involve numerous business partners, customers, distributors, manufacturers. And we saw this lately during the pandemic of COVID, how important the supply chain service for delivering the vaccinations was. So securing the supply chain services is most important. And we can see the supply chain service from different views. We can see a supply chain service as an interconnected graph of nodes, where these nodes are ICT equipment, ICT assets, and also physical assets, that their interconnection is necessary in order to provide this service. And the characteristic is that all these ICT and physical assets belong to different business partners. So this web of physical and ICT assets actually interconnect in order to be used to provide the supply chain service. So such supply chain service, it's threatened by business threats, physical threats, cyber threats, and hybrid threats. Like lately we saw in the UK how important was the business threat, where there were not truck drivers to drive the trucks to distribute the goods. So this is a business threat that actually had impact on the daily lives of the citizens. And of course, all these type of threats need to be considered in supply chain service resilience and security. And as we said, supply chain services are provided by all different economic sectors. And ESA lately published a report on threat landscape for supply chain attacks. And we realized there that the threats are not different than the threats from our systems. The cyber threats are almost the same. We had malware, phishing, web attacks, ransomware, espionage, and so on. So the cyber threats of our systems are actually the same of the cyber threats in the supply chain, because the cyber assets are actually the same as in all organizations. Now, in the project Cyrene that I participate as a consultant there, we realized that we took as a basic for proposing a schema for a supply chain service, we used the European as a template. We use the EUCC, the European Cyber Security Certification Schemas proposed by ENISA. And I remind you that this schema is actually a set of rules and technical requirements and standards that we are imposed to use for every schema. So in the Cyrene project, we use this EUCC as a template, and also we use the certification schema for cloud service that has been proposed, and using the European schema and the cloud service schema, we made a proposal for a schema for the cybersecurity schema for the supply chain services. Because you can visit our site. Now, one thing that we really, the innovative point here, which we adopted a view for assurance levels of supply chain services, and we connected the assurance level with the NIS characterization of essential services. So we said that, well, assurance level will be basic for a supply chain, that the supply chain provider actually belongs and offers an essential or important services. And so mapping how essential the services and the provider of the services are, we connected with the assurance level. And according to the assurance level of the supply chain service, so he said for basic assurance level supply chain services, the certificates may provided by a commercial assessor that applies the evaluation process, assess the conformity, uses the supply chain certification schema for assurance level basic supply chain services, and using the various standards like the 2800 series of standard for security of supply chain services and the 2700 series of standards for risk assessment, with the 15408 and 18045 for common criteria and application of common criteria. So this is the simple case where the assurance level is basic, where the assurance level of the supply chain service is substantial or high. Then we can use the process as is been described by the European schema, where we have, instead of a simple assessor, we have a conformity assessment body that undertakes this responsibility, and this CAB is supervised by the national certification supervisory authorities, and of course the certificate in this case are official. They need to be approved by ENISA, and finally final approval by the Commission. So we use this schema, this cybersecurity certification schema, when the assurance level of the supply chain is substantial or high. So the other innovative aspect in this project is that for conformity assessment, in order to apply the common criteria, the 15408, we connected it with risk assessment, and actually we developed an enhanced online ISMS that can provide all information and outcomes of a risk assessment, and this can be used by the assessor for conformity assessment as well. We did this by interconnecting terms that we see in the ISO 2700 series for risk assessment, which in this schema is the upper hand. And in the lower part, we see all the terms that we see in the conformity assessment, common criteria. So if we realize the connection of the terms, then we can realize that we can implement an ISMS that is enhanced, and it can provide information to both the risk assessor and the conformity assessor. So this is the innovation in this project. Such a similar work on connecting terms between risk assessment and conformity assessment has been provided in the annex of this newly published report that I had the honor to participate as well, where in this reporting we also try to connect the terms in order to finally have enhanced conformity assessment methodologies that take advantage of the results of risk assessment. So Cyrene, also this project, if you follow this link, you can see a glossary posted in the site of the project that actually you can find the interrelations between these terms. And I hope I didn't take a lot longer time. So thank you very much for this invitation, and I'm at your disposal for any further question.
Thank you, Ninetta. You were exactly on time, to tell you the truth.
Okay.
Thank you very much. Everything was very, very interesting. If I had to pick like two things from this very interesting presentation, I would say that I found it very, very interesting the way that you depicted the dependencies that exist between in an organization, for example, and its supply chain, and the map that is created with all these interdependencies. So it was really interesting, and it gives you a perspective of how it's not just you, your organization, but it's a whole ecosystem that should be secured as well. And I also like the fact that you propose an actual scheme in your project that contains the basic characteristics and covers also the substance and correlates the assurance levels introduced by the EU CSA to actual specific definitions in relation to the services. So I found that very, very interesting. And hopefully afterwards in the discussion with everybody else, we get to talk a little bit more about the challenges in implementing such schemes. So without further ado, I would like to pass the floor to Philippe. Philippe is the scientific coordinator of CETIC, a Belgian applied research center in ICT. He's involved in within his research in software engineering, security, and distributed systems. He's leading the task of certification for the European project Sparta, and he would like to provide an input, and we would really like to hear more about the common criteria and the certification processes. To you. Thank you.
Hi everyone. Euro, do you think you could project the slides because I'm having problems projecting?
Yes, of course. Give me a second. I will open and project my screen. Somebody just verify that you can see.
Yeah, I can see them. Thank you. Okay, so next slide. Okay, so these are just a few basic facts on common criteria. I'll go really quickly over this. It's for people who don't know much about common criteria. So it's an international standard. So where you can define in different parts. So there's a part that defines the functional requirements, assurance requirements, instructions on how to define a security specification, and an evaluation methodology. And so the basic idea behind common criteria is that a user or a group of users who need a product will define requirements, and these can be generalized requirements for multiple products that you can define in a protection profile. So these users define a protection profile, and multiple product vendors can develop different products that they will certify against this protection profile. So take, for example, a firewall. You can define a single protection profile for a high assurance firewall, for example, and have multiple vendors propose different firewalls for this protection profile. So that's the general idea behind common criteria. So it's really about product certification, and I mean, it's a detailed certification process with different assurance levels that give you more and more confidence in the I would say, verification process that has been followed. Next slide. So next slide, please.
Sorry, there seems to be a little bit of a delay. I have changed the slide.
I see slide 3. Okay, it's fine. So the current status of common criteria is, so as I mentioned, common criteria is an ISO standard, so it's really international. There was in Europe an agreement called the COD2021, which was an agreement between different European countries for mutual recognition of certification. So the idea is that if a product is certified in a European country, for example, Germany, this certification will also be recognized in other European countries. So that's the existing COD2021 agreement. And so this is being transposed in the new EUCC certification scheme, so which is the Cyber Act adaptation of the international common criteria certification scheme. I just wanted to mention that in the Sparta project in which I'm working, we've done a comparative analysis of a number of certification schemes, and this is deliverable 11.1, and where we review organization level certification schemes and standards, process-oriented certification standards, and product-oriented certification standards. So you can find a bit more information about common criteria and related certification schemes there. Next slide, please. Okay, so I'll talk a bit about the challenges that we have discussed within the Sparta project and where most of our work is focused. So there was a lot of discussion on the product versus process certification. Because when you use common criteria to certify a product, it's a lengthy process and it can be costly also. So you don't want to certify these products very often. And so this is fine when you have systems that you certify once and then they're deployed and they don't change. And this is the way it's been working in the past. So for example, when you certify smart cards, well, the smart cards stay the same. You don't update them. There's very little evolution. But when you do have products and services that evolve very, very quickly, so for example, cloud services, well, product-oriented certification is can be cumbersome and actually, I would say, unusable, because in such cases, the product changes every week or every day even, so it's just impossible to certify systems that evolve that quickly. So that's why we in Sparta, there's been some work on this alternative to product-oriented certification, which is process-oriented certification. So there's a nice discussion there that you can, presentation that you can see in D11.2. For the product-oriented certification, there was a lot of discussion that more flexible processes, evaluation processes were needed. So that's where most of the work has gone. So if you could go to the next slide. So the main idea there was to try to integrate the certification process into the development process. So that you get more flexible and more integrated certification processes. And so here on the left, you have the typical common criteria process. And on the right, you have a mapping of these different steps to, I would say, security engineering phases. Okay. And so what we've tried to do is define a process where the certification is integrated in the development process so that it becomes, you're kind of evaluating byproducts of development. And so you're kind of minimizing the certification and evaluation work. So if you go to the next slide, I've got a short example of this. So here we focused on updates. So when you have products that have been certified, whenever there's a change to this product, so even a patch, it could be a security patch, you do have to go through impact analysis. So it means that you have to gather all the evidence about the impacts of a change, a new version, for example, of a certified firewall. You have to gather all the evidence, and then you have to check with the evaluator if the changes impact any of these certified requirements. And if so, you have to go through the certification process, but you want to do this only on the parts that have been impacted and based on previous, I would say, certification efforts. So we've been working on, I would say, combining the certification process with the, in our case, the development process, and we've been using DevSecOps, so very fast development processes. This is the work we've done and are still currently working on. Next slide. So future work will be reported, and challenges as we see this will be reported in deliverable 11.3. where 2 points are mainly developed. So it's this idea of integrating certification activities into the development process so that it's faster, requires less work, just to make it more efficient. So this is one way towards making product-oriented certification more, I would say, workable for products that do change over time. And then the second idea, interesting idea, is that when you do this incremental certification, you don't want to be tied to a specific evaluation facility. So for example, the initial product is certified in Germany, and then in France, you want to make an update of this, but you want to do the incremental certification in France, not have to go back to the German evaluation facility. And so this could be done if, I would say, certification evidence is collected and shared between evaluation facilities, which would require all these evaluation facilities to work together and to share information so that product owners could certify their product, do the incremental certification where with the evaluation facility nearest to them. And a last open issue on which we have not worked, but I think is really interesting to talk about, is how can we determine if these certification schemes are effective and useful? You know, is this work a lot of work? Is it really worth the investment or not? And how could you measure that? Do we have any metrics? And what data would you need to collect to determine if a certification scheme is worth it or not? And I think this could be useful in this discussion between product-oriented certification versus process-oriented certification, which is much more lightweight, at least for products that change very frequently. Thank you for your attention, and I'll be happy to talk, answer questions later.
Thank you very much, Philippe. Very, very interesting presentation. I will stop sharing the presentation now. Very interesting. Again, just a couple of points, although all the presentation was very interesting. Thank you very much for introducing what common criteria is, because I'm not sure that everybody from the audience could have known. So it's a very, very interesting input, because it's on the basis of everything that we discussed today. I really like the fact that you are talking about a more flexible way of doing product certification from a process perspective and integrating it to the development process. It's really interesting, because one of the problems is the fact that what you mentioned also, what happens when you have an update of an ICT project and that is certified. I do recall one client of mine saying that we don't want to touch such projects that are certified, because we are really afraid of the process. It takes too long and you never know how it's going to go. And it was really interesting hearing you saying that, and as an opportunity for improvement of the schemes. I would then go to Hendrik. Hendrik is the head of the IoT lab of the company TIF Trust IT, and also company of the TIF Austria group. And he is going to share with us his expertise and his practical experience on IoT security and certification from a lab and certification body perspective. So thank you very much, Hendrik. The floor is yours.
Thank you very much. I hope you see my screen and the presentation.
Yes.
Great. Okay, yeah. I'm not talking as a working group or any other European official evaluation group or something like that, but only as a company where we do IoT certifications and other certifications. Just as TÜV Trust IT, we do a lot of IT security work in ISMS, IDaaS, cloud security, GDPR, and so on. And all this information comes together when we focusing our world or our view on the IoT devices, because we found the problem even 4 years ago, but it's still right now in the same place, that if you're a vendor of an IoT product, then you have a lot of different questions to resolve if you're talking about security. So the first question which I get always from my vendors or from everyone basically is the question, what exactly is IoT? That's a really interesting and complicated question to ask and also to answer, because in the end, IoT can be everything in the broadest sense, because our smartphones, our laptops, can be IoT devices, but also our printers, and coming down to the things where we mostly think about IoT, devices for our smart home. So devices where you normally connect your refrigerator, your vacuum cleaner robot or something else to the internet, and then it uses these connections to communicate with the internet. And as you see, most of the times when we talk about IoT devices, we have devices which cannot function on their own mostly, but they normally also need some kind of app on a smartphone, or sometimes even an application on a Windows or Macintosh device. And normally they also connect to a cloud infrastructure. So if you take this into consideration, you already see that this can get quite complicated and problematic to see what is really presenting the security of an IoT device, and what do you need to certify to validate that it's really secure in this sense. And even if you then say, okay, I identify as an IoT device and I want to get to the European market, then you get into the next big problem, and that's then IoT certification. So what kind of certification could you take right now? And that's only a small portions of the certification which are, at least to my knowledge, available in Europe. And that's, for example, here in Germany, we have this Sicherheitskennzeichen, which is basically a label, as IT security label. But we have also from our TÜV group, the CSC, Cybersecurity Certified IoT devices. But you could go also for common criteria and use that to certify your IoT device, as we saw before in the presentation before, that common criteria can be adapted and used for all other devices. So you could theoretically use that also for IoT devices. Then we have the European initiative for RED, Radio Equipment Directive, which will also include IT security aspects in the future. So you maybe already need IT security certifications and validations if you have a device which has a radio equipment device in it, so some kind of Wi-Fi, Bluetooth, or something like that. And then we come to the ETSI EN 303645, which is a standard for different other certifications like the RED. So where the RED and other IoT security standards use the basic is this cybersecurity for consumer Internet of Things standard, which also has a testing standard attached to it, which can be used to also certify devices against it. And then we have what we heard also before, the EUCC, European Common Criteria, which also is, basically can be used to target also IoT devices. But nevertheless, we still have the problem in our surveillance and our discussion with manufacturers, that oftentimes manufacturers have the problem that they change their cloud infrastructure, their app, and sometimes also the firmware on the devices quite quickly, quite fast, and also bring up new devices. And most of these certifications only then focus really on one time of certification and one version of device, which is, for example, quite a heavy problem in the common criteria world, where you only certify normally one really version of device, and if you change anything, it's a lengthy process to define if it has impact on the security or not. Therefore, we developed 4 years ago our own standard, our own certification, which heavily focused on verifying processes at the development side. So to go to the developer and saying, okay, we will check your device one time, and in this time we want to also check your process, like your patch management, your vulnerability management, your installation and delivery processes, and so on, to see that the vendor has a really sound and state-of-the-art security process in place, so that we have the assessment and the trust in this vendor, that they can also provide secure updates in the future and secure new versions in the future. We developed this standard 4 years ago because of the lack of standards in that time. Now we have a lot of different other standards which are in the European space. Nevertheless, still we mostly certify with this standard, just because the other standards have so many regulations or restrictions on different levels, which makes it most of the time too complicated for vendors to really apply to anything or to any other standard. So that's one of our main points, that from our point of view, we really need a coordinated and harmonized European approach here, where we have one standard device and IoT certification, which a vendor can use to really sell their devices all over Europe, and which is really also marketed and seen all over Europe, and not only in one country or one really specific field. And if we are talking about IoT devices, especially the cheaper ones coming from Asia, then from our perspective, there will be no incentive for them in any case to certify their devices or to implement strict IT security measures in their development environment and so on, as long as they can just sell their products over their price. And when we want to really enforce security on the IoT market, which I think we should do, then we need some kind of regulation or any other strict enforcement that these kind of IoT devices needs to be tested and certified. Because from our experience, attacks on IoT devices are different than attacks on most other OT or IT devices, because most of the time people using their IT device or using in a production way a company using their OT devices, they don't want to have any malware or any attackers on their devices. In the IoT scheme, this is not really the case. As long as the device is functioning as it did at the beginning when the customer bought it, like for example, a lamp is still turning on and off, the customer most of the times, unfortunately, doesn't really care if malware or attacker is on the device, and the device can, for example, be used for a botnet or something like that, because as long as their usability is not in any way minimized, most of the times most people don't really care about if it's can be hacked or if it's not hacked. They more care about the price and the usability of the devices. That's basically my presentation. Thank you for your attention.
Thank you very much, Hendrik. I'm really happy. Very interesting presentation also in this case. I'm really happy because we kind of created a circle. In the beginning, Roberto also mentioned about the interconnection between certification and standardization, and Hendrik also mentioned that one of the problems that he perceives is that we have this lack of standards, or we have too many standards but not harmonized enough in order to have unique solutions, and that creates a problem. And I really enjoyed his position, and also all the other practical things about IoT and how differently perceived and how certification should apply to them. But we should keep in mind that they have peculiarities, and on criteria may not be the best solution. Kind of a circle. I would like now to pose some questions. I'm looking at a question and answer tab on the platform. I don't see any questions that have been posed by the audience. Maybe Antonio can help me out. Is there anything on there, or should we proceed with some other questions that we have collected?
No, I think you can proceed. There is no relevant question to the panel. There is other question now. Yep.
Okay, great. So the first thing that I would like to ask Roberto, we already heard from Philippe and Hendrik regarding some of the challenges that common criteria and certification of products actually face. Can you provide us also with your own opinion regarding what is the biggest concern or the biggest obstacle that you perceive or perceives regarding cybersecurity certification of products?
Okay, thank you for the question. So I'm gonna provide my personal viewpoint of view, so rather than ask about that. So I would say that one thing, I mean, is clearly when we look at I already mentioned during the presentation, I think that it is important to ensure that there is a close cooperation between the manufacturers and then the evaluators, especially because, you know, the new cybersecurity certification schemes like the UCC will require like these aspects linked to the patch management and also the vulnerability disclosure and also continuous compliance. So this it's one important aspect to look at. But if we consider also overall all possible cybersecurity certification schemes that are going to be defined under the Cybersecurity Act, so I would say what would be important is to ensure consistencies across all these schemes, because I think Ninetta already mentioned, but also Hendrik mentioned that most of the time, you know, we end up like combining these schemes. So reusing, for instance, if you look at simple IoT, so we have an IoT devices with a backend that this could be a cloud service that could be combined and then provide a more complex service. So these are questions how to deal with this kind of situation, and then, for instance, what could be the final assurance level. And so with respect to Axel, we are trying to answer to those questions by looking at the composition approaches. It is also something that is linked both to Hendrik, but also to what Philippe has mentioned in his presentation, that we need to have, let's say, a continuous evaluation and then add bits and bits, you know, and then see how the product could evolve. And then in case whether certain requirements might be invalidated because there is an update, and so how to deal with that. So I would say that consistency is one important aspect to consider. Cooperation, so ensure that all the different stakeholders are around the table, you know, to work together. And one, for me, big challenge is going to be the monitoring of the compliance, but that we are going to see how this will happen later once we have at least the first cybersecurity certification scheme in practice available like UCC, and then to see how this could be achieved in a good way. And finally, yesterday I was also joining a discussion about UCC and so on. One important point of view is to look at worldwide, because I mean Europe is not in isolation, but we have to consider that products that are both developed by European companies but also third-party companies. So we have the markets that are interconnected. So we need to ensure that there is all these aspects are taken into account while still respecting the European legislation, the European regulations, because this is key important.
Thank you, Roberto, very, very much. I think that you summed up the challenges very well. And I especially like the fact that we should go on. The next step should definitely be one that shows cooperation, that we're sitting, all of us, all the interested parties in a table, and that we are not one against the other. As an auditor, I have very often felt that we are, with the client, we are on opposite sides, but in the end, we are all on the same side and on the society's interest and the personal interests and freedoms of everybody. So I'm sorry, I cannot address the question to all of you because we don't have a lot of time, but I would like to hear just one input from everybody regarding what do you think should be the next scheme that ENISA undertakes to implement. So we already have the basic, the one, the EUCC that we already mentioned. We have the cloud one that is almost finalized. We have a mandate that says that 5G should be implemented as the next one. What is your opinion? Ninetta, can I hear a proposal?
I will follow Roberto's comment before I answer to this question. And as Roberto mentioned, I think that we need to see, first of all, the UCC in practice, how, I mean, at least in Cyrene, try to put this in practice by applying it to supply chain service. I think before we need to see a lot of, to have some trials first before we move to the next schema and to the next certification schema. Also to really solve the challenge on interrelating and interconnecting the existing standards. Because, just putting in a scheme a bunch of standards that, okay, they relate to the specific product, it's just an academic statement. If you want to put this in practice to see at the end how the standards interrelate and how you can achieve a method, a conformity assessment method that with one method you can audit the compliance of all standards that are related to this product. I think we first need to solve such challenges and put standards and conformity assessment methodologies in practice before we think of producing schemas.
I understand very well. First we walk and then we run. I get that as a baseline. Okay, Philippe, something to add, and then Hendrik as a last point.
Yeah, I think we need to focus on, I would say, areas related to critical infrastructure. So yeah, I think IoT is one that should really be covered. But again, that's a complex area because of the diversity of systems that do use IoT devices. So that would be my I would say my area where we need a Cyber Act scheme.
Great. And taking 1 minute from the next session, Hendrik, your comments.
Yeah, it's definitely clearly also IoT, as you saw in my presentation. But on the other hand, I also would like to see a little bit more focus on the OT world. We have their standards in the OT world, but nevertheless, there are huge ransomware attacks and huge problems in the OT environment, which is normally not so clearly assessed or addressed as we have in the IoT and in the normal product world, like smart cards and so on. So the besides the IoT world, which is definitely something where I would take my focus on, it's definitely also the OT world with the production environment, which I see under a lot of different attacks.
Thank you very much, Hendrik. So thank you very much, all of you. I really enjoyed the presentations. It was very, very valuable. I hope we managed to convey to the audience that certification, cybersecurity certification in products or processes has just started. It has a lot of way to cover, but it's definitely something that we need to deal with at a policy level, at a European level, at a manufacturer's level, at the standards level, from all the very many perspectives. And it's definitely a subject that will be in the forefront of developments in the next years. Thank you very much to you for presenting this. Thank you very much to the audience, and I give you to the next presenters. Sorry for the short delay. Bye.
No worries at all. Thank you very much, everybody.
Thank you.
Thank you.
Thank you.
Okay, so the next session is going to be a demo, collaborative KYC. We have on the stage both Robert Norville and Mario Mawat. I will let you introduce yourself, guys, and the floor is completely yours.
Sure. Thanks, Antonio. So my name's Dr. Robert Norville. I work for the University of Luxembourg, and we're working on with CaixaBank the collaborative KYC use case. So we have a few slides and then a demo that we'll go through, but I'll give the floor to Mario to introduce himself.
Hello, it's Mario Mawat. I'm working in CaixaBank as Director of Security Innovation Transformation. And yes, we are working together for this collaborative KYC together with Rob, and we'll try to present what we have done so far and a demo.
Sure, thank you. So if we go through slides quickly. So I'll try and keep this brief because we want to get to the demo. But the problem we're trying to solve is that currently we see that KYC, which is Know Your Customer, which refers to a group of laws that banks have to comply with to be sure they know who they're doing businesses with, that they know who their clients and customers are. This is very fragmented at the moment, so it's repeated. It's often manual. See that the client has to take their documents often physically to every bank they do business with. So here we have increased security risks because one, we're dealing with non-standard paperwork in a lot of cases, and two, because it opens up the possibility that banks would have out-of-date information about their customer. So that's roughly the problem we're trying to solve. Mario, I don't know if there's anything you'd like to add from CaixaBank's point of view.
Yeah, that this is a process that is impacting a lot to the business because finally the convenience of the final users is affected. They know that it's something that regulators are obligating us to do, but at the end. It's not only something that we have to follow because regulators has pushing us to do it, but also users sometimes they don't understand what they have to provide all this information, all this documentation, and it affects to how they enroll to the bank, and also well the requirements are quite tight, so it has to be presentially normally. So this sometimes customers they cannot do it. So it's something that is affecting all the banks. So it's not a question of competitiveness, but it's impacting the business also. The problem is that if someone cannot bring all the documentation, we have to block the user. So the impact is very high. So and a customer that cannot use the financial services is one of the most negative things we could do. So the impact is very, very, very high.
Sure, thank you very much. So Mario mentioned a few really important pain points there that we look to solve. So we have a blockchain-based system. And the idea here is that the customer can provide documents once to any bank that they have business with. And these documents can then be shared amongst other banks that the client has business with, providing the client gives permission for this to be the case, of course. So no data moves without the client permission. And once that permission is given, then the data can flow digitally. So here, obviously, we make sure that the banks have up-to-date information. As Mario rightly says, it's a collaborative approach. So it's not about competing here. It's about working together to ensure that we provide the highest security possible for clients and customers, and also reduce, I would say, false positives there. So obviously, we don't want anyone to have anything like frozen accounts or not being able to access their funds if there's an error. So we help reduce the errors in this case as well by making sure that digital, verified, up-to-date information is always where it needs to be. You'll notice the euro symbols here as well on this slide. So what we did to encourage the flow of data is also add a form of data monetization. So banks that collect and verify documents are financially rewarded when they share those with another bank. So very large banks sometimes say to us, this is all well and good, but it was a lot of cost for us to collect these documents. So why would we give them away, which is a perfectly reasonable thing to ask. So we look also at the monetization of data to ensure that all parties see the benefit of this increased data flow. So our solution, I should say, works just as well for business clients as it does for retail clients. Anywhere there's a need for information to understand who the customer is. Possibly works better in complex cases. So the more complex the case, the greater the cost and the greater the risk of mistakes. So we aim to eliminate that by having this rapid, near instant data flow. You'll see most of this in the demo anyway. So just to briefly say, we make use of blockchain, which allows entities that are possibly marketplace rivals to collaborate with one another. We use the blockchain to store customer-controlled data access permissions, records of payments, records of who had access to which data when, where data transfers took place, which gives us a really great kind of audit trail so we can ensure everyone is in compliance and that everyone has access to the data they need to. Mario, I don't know if you want to jump in there and add anything about the technology from your side.
Yeah, that blockchain fits very well here because we need the traceability. We have to report to the regulators how and why we are collecting all this information, and take into account that sometimes there are different regulators here. Each country in the EU have different requirements. So sometimes we need to know exactly from where are coming these documents, how they have been collected, and blockchain is providing here the most suitable solution. So it's fitting very well.
Great, thank you. Yeah, and the cross-jurisdiction point is an important one there. I think we can say that in the EU, all banks have to conform to the same rules, but their internal processes for doing these might be different, and how EU law is translated into national law might create some slight variances in approach between nations as well. So how we do it, we make heavy use of APIs. There's a blockchain behind it, as you've already seen. And here you can see two banks exchanging data. So one bank, in this case, Bank B, CaixaBank, makes a request for a document. Bank A is able to provide it. So they send the digital copy of this document and the verification that the document is genuine over. And then the funds flow back the other way. So in this case, Bank A is financially rewarded for having provided the documents. And again, here it's important to stress that because we're dealing with personal data, the access control is key. So this can't take place without the client first giving permission for it to be that way. So we've been doing some work to integrate our system with CaixaBank. It's now deployed on CaixaBank systems. Due to the situation with the pandemic, we managed to do this completely remotely. So it was a little challenging, but interesting and good to know that we can operate complex systems and work with complex systems without actually being present in them. And going to something Mario touched on earlier, we make quite a lot of use of metadata. So in addition to the blockchain providing a record, when we share documents, we share them with information about, for example, which tools were used to verify it, when the documents were verified, when their expiry date might be, or when it needs to be checked again according to law, things like that. So again, trying to provide assurance that the data is always as up to date as it can be. And these metadata requirements are something that's come out of the work we've been doing with CaixaBank and the feedback we've received there. So the big piece of news for this event is our first full international test. So you can see on the map there we have CaixaBank in Barcelona, us as the University of Luxembourg in Luxembourg, and we have a server running in Netherlands as well. So we were able to perform tests where we created customer profiles, created and checked customer permissions for banks to access data, and then traded example documents within the system. So here we've shown that we can do it between different organizations, between different jurisdictions and nations as well. So we were very excited for this to take place. I think next steps, we're looking at working with other partners, other members in Concordia. So we're going to try and integrate a verification tool, which was developed by the Cyprus University of Technology. There's some work to do there around APIs and exactly how we integrate that. And I think we've also been discussing with CaixaBank the possibility of kind of inter-CaixaBank tests or operations. So if different entities within CaixaBank have a need for information, we could also look at helping them make that flow more easily. Mario, I don't know if you'd like to add anything there about that future work.
Yeah, well, that KYC processes could be also interesting to share information between different industries, for example. It's not only between banks. We could explore this option, and for example, in CaixaBank we have different subsidiaries, and they are running different business. So perhaps we could try the solution for this, and also we have banks in other countries in Europe, for example, in Luxembourg, by the way, and it could be easier to start applying this internally, because it's something we already need, and we will not have any problem for privacy and other possible issues, and well, it's as a future steps it would be convenient.
Sure, yeah. So we're really excited to get started on that, and I think through doing so we again reduce the risk of kind of identity theft and fraud through making this information flow more easily. So that would be it for the presentation. So onto the demo now. So you can see here we have two instances of our system running. So they're running with a full blockchain behind them. So if you can think of the left-hand side of the screen as our first bank, let's say it's CaixaBank here, and the right-hand side of the screen as another bank. So we're going to look at how a data trade can take place between these two. So the first thing I want to go to is, as we mentioned, the data monetization. We have a function here to check the balance of the bank. You can see here that this bank currently has 138.50 as its financial balance within the system, and our second bank has 61.50. So you should see those change as we go along and documents are exchanged. So what I'm going to do first is add a client to the system on our first bank here. So I've already filled out the details, the ID that we'll use to refer to the client, type of document, the complexity of the document. You can think of this as a tool that was used to verify it, name, and the number on the document. So to my documents here, see we have an example of a Luxembourgish ID card that we're going to use. That, and then execute, we will upload this document. So here we get the response, successful. We get some of the IDs that have been created on chain for the client. We don't need to worry too much about that, but the important thing to note here is, you see in my terminal, this is the blockchain transaction. So when we're making these additions of clients and permissions, that are happening live on the blockchain behind the scenes there. So let's say our client that we've just added wants to join our second bank over here. In that case, the first bank, the bank she's already a customer with, will generate what we call an onboarding pass, which you can think of as a one-time password that you can use to give permission to the second bank to access her documents. So the first bank will generate the pass. So this is unique and single use, so it can only be used once. And then we will, second bank here, check it, so we can check that it exists. You see here that the response is 200, so everything's okay. This pass does in fact exist. It hasn't been redeemed, meaning that it's not been used yet, so it's valid. And it hasn't been nulled, meaning it's not been lost, it's not been cancelled, anything like that. So this is a valid pass that this bank is assured that it can use, again, using the provisions of the blockchain. So what we're going to do is get client, so give client an ID for the bank on this side. We want access to the first tier of documents, which is in line with said here, so first tier of documents. And then we're going to put in the onboarding passes provided by the client. Just finish executing. You see there we have success. The client was added successfully, and that results in another blockchain transaction here. So we now have the client on recorded as a customer of both banks. So now the permission's been granted, we can move on to getting access to any available files. So to put in the client again. And then we want a particular document class. In this case, it's an ID card. Put in D. Execute. So, okay, so we have the response here, 200, so everything worked. And if I download this file and open it, see the same ID card. So the permissions here were granted and controlled on the blockchain, and the file was transferred from one bank to another once we had customer permission to do so. Now, if we go back down to our check balance functions at the bottom here, again, you'll see that the numbers have changed. So the bank that provided the document has a greater balance, and the bank that utilized it had now has a lesser balance. So this is the incentivization for banks collecting data to share it with their peers in the network. There's a few other things we can do with the system here. So we can add documents with different tiers, so documents with different complexities. And we can check those as well. For example, yeah, here we add a new file. The process is the same, so we would put the client ID, document class, and the tool that was used to verify it. And when we do that, we can transfer the files exactly the same way between the two. So there's a few more advanced system features, of the system, but that's the basics of it. What we want to do is use the blockchain to record and control access and allow these documents to be shared and participants to be remunerated when they do share. So we're a little ahead of time. I'm quite happy to take any questions, and that's it for the demo portion today.
Okay, thank you very much, Robert. Let's see if there is any question from the audience. So I remind everybody that you can write your question on the live chat on the right of your screen, or there is also like a question and answer section that you can use. So let's see if there is any question. Okay. There I can see. I mean, I can ask already. There is already like a public report on this product that is available for the general audience.
So if you mean by report kind of article, then yes, we're putting one out through SMT channels now.
Okay.
As soon as that's finished and available, I'll happily share it with you and the rest of the Concordia community.
Perfect. And so all the audience can find it also like on our Concordia website.
Sure, yeah.
Perfect. Okay. I think there is no question. So I would say we can close it here. Thank you very, very much for this demo, both of you. And we are having like 20 minutes, 20 minutes of break before the award ceremony of Concordia Women. Thank you very much and see you soon.
Thank you, Antonio.
Thank you. Goodbye.
Good morning. Can you hear me?
Yes, we can hear you.
Okay,
Hi.
perfect.
Hi, Eleonora.
Hello.
Hello. We are not online right now, right?
Sorry?
We are already online. No.
Yeah, we are already streaming on Teams. Yeah, the whole yes. So we're just waiting a couple of minutes, just that we go sharp to 3:45, and then we can start.
Can I start sharing my?
Yes, sure.
By the way, so nice to see you, all of you.
Hello, hello, yes.
Yeah. Hey. Okay, Antonio, I'm waiting for you to start.
Yeah, I think you can start actually. It's 3:45. You can start. People are online. So, welcome back from the break. And I'm happy to have here like a session only women, because this session is specifically for the Concordia Women Awards ceremony, and I will leave the floor to Professor Carminati. Barbara,
Thanks.
please go ahead.
Thanks. Hope you can hear me. Good afternoon. It's really a pleasure to me to welcome you to this section that, as you can see, is dedicated to women in cybersecurity. As you might be aware, since the start of the Concordia project, we have devoted effort and time in defining and implementing action to promote women in cybersecurity. During the first Open Door 3 years ago, we launched the Concordia Manifesto in collaboration with EXO Women for Cyber. The manifesto is basically a document where we analyze the situation of women in different domains related to cybersecurity, and we identify three main objectives that we, as a Concordia, we would like to achieve. This was just our starting point. Then, based on this objective, we have identified a set of and start to implement a set of action, indeed to incentivize the presence of women in cybersecurity. One of the action is indeed the reason for which we are here today. So Concordia has established the Women Awards, the Concordia Women Awards, to celebrate women in cybersecurity, to recognize outstanding women working in cybersecurity, and to encourage young female working in cybersecurity to continue their career. The Concordia Women Awards are defined as a series of awards that will cover different areas of the cybersecurity ecosystem, and the first has been devoted to research category. In particular, to promote the women at various stage of their careers, these awards include three main categories, as you can see from this slide. The first is a master student, so we want to recognize young female that since the master study, the master thesis, they are interested in topic related to cybersecurity and privacy. Then we have the PhD student that, as you can figure out, we are targeting PhD student that have investigated topics related to cybersecurity in their PhD study. And finally, the early career research. So we aim to prize young female researchers that, what does it mean young? Here young means that they have discussed their PhD thesis no more than 5 years ago. So we received several excellent applications. We are really happy about that. We formed a selection committee that I would like to personally thank. In this slide here, you see the name of the professor and the person that has been involved in this committee. The committee has did a great job because they evaluated each application. And then based on the judgment, we are happy to announce the winner of these awards. So the awards winner are for the master students award with Pantelitsa Leonidou from Cyprus University of Technology. For PhD student award is Martina Sestak from University of Maribor. And for early career research is Eleonora Luziuk from University of Padua. So I want to express my congratulations to Pantelizza, Martina, Eleonora. But this session is not only to announce and to congratulate with you, but it's to give the opportunity to introduce yourself and your topic. So in this section now we are going to leave the floor to them. We start with Eleonora, and then we go for Martina and Pantelizza. So to all the audience, feel free to pose questions in the audience, in the chat, sorry, and then I will moderate the question. So Eleonora, the floor is yours. I will stop sharing.
And I
So
can
you should
share
be
your
able to share your.
Okay, can you see the presentation?
Yeah.
Okay. So good afternoon, everyone. It's a pleasure to be here. So thank you very much to Professor Carminati and all the people that have been involved, not only in this big project called Concordia, but also in this such a big event and initiative, which is the Concordia Women Awards. I'm really proud to be selected for the Early Career Award today. So what I would like to share with you is my brief career so far. So I discussed my PhD 3 years ago, and the current project, the current research activities that I'm working on. So very briefly, I started and I have a background in bioengineering, and I got a PhD in bioengineering and bioinformatics in 2018 from the University of Pavia. And then I moved to Padua to join the Spritz Security and Privacy Research Group led by Professor Conti, where I've been a postdoc till last May, when I won the assistant professorship position. And I'm still working in the Spritz Research Group. From a research point of view, my interest mainly regards the Android security, and in particular the Android virtualization technique, which have been used so far for developing new defense mechanisms, but also new attacks, and which I've also used for writing several project proposals, among which three actually were considered successful. So the first one was a Marie Curie Global Fellowship, which was considered a successful project last year, and for which I was awarded a Seal of Excellence. And the second one was a Fulbright Fellowship, which is also the thanks to which today I'm currently calling you from Berkeley, where I'm visiting the International Computer Science Institute. And finally, this year, recently, I was awarded the Early Career Women Research Award from Concordia. Over my career, the event that made me switch from the my previous background and research topic that was more connected to bioengineering towards the current one, which is cybersecurity, was an internship at the PFL that I did during my last year of my PhD in 2017, which was the opportunity for me to visit a research group working on mobile health cybersecurity projects. And then it was also I got the chance to start working in cybersecurity in that occasion. Besides doing research, you know that at the university we do a lot of stuff. So I'm involved in several nice activities like the Cyber Challenge event, which is an educational program for which we're going to move towards the 5th edition next year. I've been from the very first edition, the local instructor for the UniPD team, and the first time in the first edition we won the national prize. I've been also involved in proposing a patent 2 years ago, and in organizing several international events, like 2 years ago, several PhD schools on cybersecurity topics. Last year, an event to promote and to share the experience and the contribution of women in both cybersecurity and computer science. And recently, we organized with other partners of this Arcus program, a summer school in cybersecurity last September. Finally, I'm very proud about the mobile security course that I am a teacher of, and I've been able to set up from scratch in Padua within the framework of the new cybersecurity master degree that has just started, and I'm really proud of. Concerning the research activities that I'm working on, over the past few years, I've been, as I said, I've been working in the Android virtualization technique from different point of views, and I recently switched to something that might be more challenging and tough as a as an overall scope and purpose. So the target of my current activities is the Android Security Program, which is sponsored and suggested and promoted by Google to support the responsible disclosure of vulnerabilities that everyone can find in the Android operating system. Even though the program is pretty simple and involves a few steps, some of these steps might be bottlenecks and can affect the security of the Android operating systems every day. So everything starts with the identification of a vulnerability in an Android operating system, which can be done by anyone, a researcher, professional developer. Anyone can find a vulnerability and can responsibly disclose it to Google, which has to evaluate the vulnerability and eventually to release this associated security patch, which is published as part of the Android official operating system. However, Android is a very complex ecosystem because besides having the official Android version, which runs on Google devices, we also have a multitude of different customized Android operating systems that run on the different devices provided by the mobile vendors, such as Samsung or Huawei. So if you have a Samsung device, you will have a different customized Android version with respect to the one that might be running in a Huawei device. And this fragmentation problem actually is significant because whenever there is an update, a security update provided by Google, it is the responsibility of the mobile vendors to integrate such update in their own customized version. And sometimes they don't do that. So at the end, what happens is that mobile users might never receive the security update, either because Google does not develop the security patch for the vulnerability that has been detected, or because the mobile vendors do not integrate the security patch in their own customized device. What I'm working currently is to propose an alternative approach to solve this problem and to provide a new solution that helps with the development, but also the distribution of the security patches, which relies on the Android virtualization technique. Such technique allows basically to have multiple instances of the Android operating system that run at the application layer, so on top of the Android native operating system, and that are independent, do not have dependencies from the underlying operating system itself. So everything is handled by an application which is called container that is responsible for creating the virtual environment. And within the virtual environment, you can have multiple applications running at the same time. So the idea is to enable the development of the security patches as security plugins of a virtual environment so that at runtime, the mobile users can simply download the security plugins and install within the virtual environment and provide the security protections they would like to the app that are running in the same virtual environment. Going a little bit more specific within this technique, everything goes around the internal design of such a container application, which involves, of course, several plugin apps, which are the one that we run in the virtual environment, and one module, which is the most important one, that is called proxy module, because it is involved in the interception of all the system calls and the APIs that are called by the plugin app and their forwarding towards the Android framework. So basically, this module is able to change at runtime the behavior of the application that are executed in the virtual environment. So exploiting or relying on this proxy module, the plan is to, as I said, is to enable the runtime dynamic loading and execution of several security plugins that will be enhance the security protection of the virtual environment and at the end provide the security patches that are associated to a vulnerability that has been found. Thank you for the attention, and I'm happy to answer any question if there is.
Thank you, Leonora. Let me see if there is question. I don't see in the chat question, but no. But I actually curiosity because by the way, congratulations for your Fulbright. Wonder what are if you can tell, what are you doing in Berkeley and what are the topic of your Fulbright? if it's related to this.
Yeah, it's actually related. I mean, Android virtualization is a very huge technique that can be addressed from several perspectives. So even here, I joined the group of Professor Serge Egelman, and they are doing like privacy. They are focusing on privacy issues, and another time the virtualization technique could be, let's say, a new approach for solving some privacy issues that they have encountered on the Android operating system. So we are trying to merge our background knowledge in order to provide something that could be new for the Android community. So at least that's what we can manage.
Okay, sounds a good plan. Thank you, Leonora. Thank you
very
much. I think we can go on for the next presentation, which is Martina. As you can take the floor.
Thank you. Just let me think real quick. Okay. Okay, now you should be able to see it. Okay, so hello everyone. On my side, my name is Martina Šestak. I am a PhD student here at the Faculty of Electrical Engineering and Computer Science in Maribor in Slovenia. I am this year's PhD student award winner. So thank you committee, thank you organizers for this recognition. And I'm currently employed also as a teaching assistant and a researcher working on various projects here at the university. My areas of interest mostly revolve around graph databases. So I have a background in software engineering. So besides the research part, my days are occupied also by development and implementing things that can be used widely. But in my PhD studies, I have worked on publishing as many research papers that the time allows us. I am yet to obtain my title so that I can start writing project proposals and things that my other colleague is already doing there. These are some of the publications that I have published so far. And now in the following slides, I'm just going to try to give you a brief look into what I do in my PhD. So I'm working on developing a model, an abstract model that allows you to, let's say, detect or observe some suspicious patterns, potentially fraudulent patterns in networks. So what I'm trying to do is combine my, let's say, graph database knowledge together with the graph theory foundations, and then apply these findings in the fraud detection domain here. So just to give you a brief context to the research problem, so we have many domains today that are basically, let's say, networks with highly connected data. And now graphs are considered to be mathematical representations of these networks. So this is something that's an axiomatic statement there. So graph database technology is something that was developed with that purpose, so that we can apply the graph theory concepts there.
Sorry to interrupt.
Yeah.
But could you please try to reload your presentation, because I see a green box in the some words are.
Sorry. Okay. Let me just start it there. Thank you. Okay.
Sorry for that, but since this.
Yeah, is it better now?
Okay, now the box are no.
Okay, let me just check something with my display settings. Sorry. Very quickly.
No, because some words were covered by the box, and maybe you refer to that sentence as well.
Okay. Quickly. Okay.
Seems to be the WebEx box, something like that, I guess.
Maybe I can.
Can you move or reduce?
Yeah, like that. Hide it something. Is it better now? Okay, great.
Thank you so much.
Thank you. Okay, so what I was saying is that basically the graph databases are then a technology that became popular with the social networks in the last decade there. And what's, let's say, new and popular about this technology is that you can represent this network data directly or more natively as a graph, basically, because the underlying data storage structure in graph database is a graph. So you have nodes, you have edges, and then you have labels of nodes so that you know that we have, for instance, users in a product review network, we have reviews, products, and stuff, things like that. And we have properties describing these nodes. And this kind of technology is, let's say, optimized for storing these connections, because the main idea is that when you are researching or analyzing networks, let's say in most cases, the most relevant or important information for you would be to analyze the connections between nodes. And this is something that graph databases are quite good in covering there. Now, on the other side, we have the fraud detection problem, where you're trying to study the network in order to analyze any potentially fraudulent behaviors. Another question here that arises is that if you can represent networks as graphs, does fraud detection in network come down to identifying patterns in a graph? So using graph algorithms that would allow you to analyze such networks here. The answer is more or less mostly yes. So if you look at the literature, there will be, let's say, two types of categories of approaches. So you will have the modern data mining, machine learning based approaches, where you study the network, you study the graph basically, and using different statistics such as what is the degree of a node and things like that, you are able to, let's say, perform clustering of nodes which are potentially fraudsters in your network, or you can classify, label a specific node as a fraudulent node or not, and things like that. And then on the other side, you have the model-based reasoning approaches, which rely more on the expertise and the knowledge of the domain experts, basically. So you have experts, let's say, telling you or helping you build a database of fraudulent patterns. And then for any new pattern that you have in your system, in your network, you can use this database to say, okay, this new pattern might be also fraudulent or not. And this is, let's say, a starting point for my model. So I'm more leaning towards the model-based approach there, where I'm trying to build an abstract K-card model, which is based on the graph theory concept and can be implemented in modern graph databases so that you can actually use it on your graph or network data stored in a graph database, and therefore prevent or detect possible frauds in your network. So the model itself encompasses various things. So let's say it's a comprehensive approach, which allows you to specify what might be fraud or not. And this is done based on business rules of the domain. So basically, I am using the cardinality constraints concept, which allows you to limit, for instance, how many reviews a user can write for a given product. So if this number exceeds, let's say, 2 in a month, then I know, okay, something potentially fraudulent might be happening in my network. So basically, this is the kind of a rule that you specify in the system, in the database, and then you can use the model's algorithm to check the existing network data or have it as a preventive measure to help you maintain the database integrity so that it cannot happen that a user wants to write a new review on your data, on your products. So this is a visual representation of such a model here. So if I were to have a graph database with a graph with similar structure, for instance, I know that potentially fraudulent patterns in my product review networks are when users are writing massively positive reviews for the same products, and they're all rated 5 or 1 if they're massively negative, fake negative reviews. And we don't have, we don't know if the purchase has been made. So they're simply generating massively fake reviews here. And the model enables you to specify such a rule that would keep make sure that in your database that situation doesn't happen, or if it already happens, so that you can detect where it happened. So which are the connections that are or subgraphs basically which are fraudulent there. So if we were to have such a network here with all of the users, the products that they wrote and things like that, and I would say, okay, a user can write at most one review for the same product if he hasn't purchased it, then we can run the algorithms, which would then detect us, okay, we have more than one relationship here or here, for instance. And in that case, we could say, this is the subgraph where I have, for instance, this user writing massively fake negative reviews, trying to diminish the value of some product or something like that, or massively positive reviews, so that the grade in general of that product is better, for instance. And just to sum up briefly the impact of this PhD research, so it has been already published, and now I'm just working towards my dissertation here, but this model should be abstract enough. It's based on the graph theory concepts, and it's something similar that, somewhat similar. It extends the work that has been done in relational databases, but it hasn't been done for graph databases. Also, I would say the biggest value is the applicability of this model, because it's abstract, but also comes with a set of algorithms that allow you to implement it in modern GDBMSs, in modern graph databases, and you can specify complex patterns for detecting fraudulent behavior in your networks here. And of course, there may be even more that I haven't discovered yet, but more or less, this is it. And this is all for my presentation. If you have any questions, I would be very happy to answer them.
Thanks, Martina. Let me see if there are questions. I need to for another monitor. I don't see, but I will check after. Yeah, first, congratulations for your thesis discussion. I follow your presentation. It's really good topic. I have some curiosity for that. I can ask to you. The first is about the business rule. You mentioned business rule, and I wonder if the business rule for fraud detection is something that are very, let's say, clear and well defined, or is something that you need to evaluate on your data set. And in this case, you can plan to evaluate in the graph data set.
Yes, so these business rules are, let's say, a subset of, there could be various rules that would help us to detect such patterns, but mostly these rules are focused on the number of interactions between entities. So if I say how many times does a user write a review, for instance, that's something that can be transformed into something that monitors the connections in my graph. So how many relationships I have in my network for my network elements that I can map or represent via a graph in a graph database, and then these rules can within this model can be used. Of course, it doesn't cover all of the rules, all possible rules, but let's say a subset of these rules that are focusing on the connections between network elements.
But this is just my curiosity. Does the graph modeling give the opportunity to have a more complex business rule compared to, for example, the database model, the traditional database model? Do you have the opportunity to define new business rules? Or something that maybe I've considered in your research?
Yeah, that's an interesting thought there. It doesn't at the moment, and this is precisely why I'm working on extending it, because this business rule part, the procedures, so business logic incorporated in a database. In graph databases, this is quite, let's say, a work in progress. So there's still a lot to do before it can match the relational databases, for instance. But the thing with the graph model there is that you can directly represent these connections between the networks. So it's much more natively done here. So at the moment, it already allows me to specify some more complex things there. And I expect that it could also do it should there be more complex mechanisms developed there.
Good. So
thank you.
New challenge to face.
Yeah, quite a big
Thanks.
there.
Thanks for your presentation, and we go to the list, but the last but not the least. Sorry, we have Pantelitsa. So you're here.
Hello. Hello, everyone. Let me first share my screen.
Yeah, the floor is yours.
Perfect. I think that you can see my screen, right?
Yes.
Okay, first, I would like to thank you, Professor Carminati, for introducing me to the panel, and also to just express how honored I feel about the Master Awards. My name is Pantelitsa Leonido, and now I received the Master's Award, but now I am a PhD candidate at Cyprus University of Technology. I'm working on cyber safety topic under the cybersecurity. And the study that I was doing during my master degree was about how to enhance the social media experience of minors by using adaptable and usable cyber safety tools. Let me minimize this. Okay, the motivation behind the study was that since the social media applications are not designed and developed especially for minor users, and the minors used to overuse the social media applications, and sometimes they are using multiple social media applications that their parents don't even know that they're using. And that exposes them to many risks and dangers that are not capable of coping with. Some of the cyber safety threats that the minors can face online can be cyberbullying, inappropriate sexual or violent content. They can be exposed to hate speech videos or posts. They might post some sensitive information or receive some sexual grooming messages in their chats, or by sending pictures to unknown people. And what we try to solve here is to protect the minors when they are online. And since that is not a very new problem, we know that the researchers and developers have designed and developed many cyber safety tools to protect the minors online. But the problem is that most of the existing applications, after studying the literature, we realize that are underused by the parents since they have many usability issues, and they are offer services that are mostly for monitoring the activities of the minors or restricting their access to those applications. And that is most of the times too privacy invasive for older children like the adolescents. And that makes those applications unwanted for the minors, and also grows tension between the parents and the children. So the aim in our study was to redesign and improve the cyber safety tools, or actually the methodology of designing and developing the cyber safety tools in order to satisfy the requirements also for the children. The two main approaches in the literature that are used to design those applications is the parental control approach, which is the more traditional one, where we have the monitoring tools and the restriction tools, where they apply some limits on the time or the applications that the children can use, or maybe the parents can monitor the chats or the profiles of the children in order to understand if they are exposed to any risk, and then they need to manually do something about it, maybe offline or online. It depends on the tools. But the problem of this approach is that it mostly offers interface only for the parents, and on the children device there is only some background services that are running without any interface for the children. And that's, as I said before, too privacy invasive for the adolescents, and sometimes make the children's social media experience to suffer. And that this approach is mostly suggested for children of young age. And then more modern approach is the self-regulation approach, where we have the self-monitoring and self-regulation tools. And also we have the risk coping guidance of the minor. So in those applications, we allow the children to be exposed to the risks at the level in order to learn how to monitor their own activities, to set some regulation techniques and some risk coping techniques. And those applications are promoting the collaboration between the parents and the children, and usually offer interface for both the parents and the children. And in those applications, the parents' role is mostly to offer help in the risk coping when the minors face any online risk. And this approach is mostly suggested for the adolescents. Some other suggested features in order to increase the usability of those applications, the cyber safety applications, is to add some educational features for both parents and children, to have always some direct links or connections from the applications to some organizations that are specialized in the online safety, where the parents and the minors can report incidents or get some online help. And the third feature is to add some gamification features on the interfaces of the children in order to make the applications more friendly for the minors. So the idea was to, instead of having one approach in an application, either the parental control or the self-regulation, is to have a more adaptive approach for minor cyber safety. That this application can be adapted based on some factors such as the age of the minor, the family values, the variation of the different parental styles that someone can follow, or maybe some cultural characteristics. And by having an adaptive approach, then we aim to fulfill both the parents and the children's requirements. And the idea is to start collecting all the existing application features and user requirements about cyber safety applications, and to identify different categories of the parents and children categories, and also identify which features are go into under each category, and then identify the conditions where the application needs to adjust its feature. For example, a condition can be when the child gets older, or maybe when a child starts having some dangerous activities, and this is monitored by the parent, and then they can change maybe the settings and give him less freedom in his activities and more control. Then we were about to identify the latest technologies for each feature, and then design and develop the adaptive cyber safety application. And in the end, evaluate this application with real users and go back again in the circle by collecting the new, maybe some problems that we will face or new requirements. Since that was a very, it was an idea to just suggest a new and a different approach, but we didn't have the time during my studies to focus on implementing the whole application. I needed to move to a more focused point. So my master thesis was mostly on federated learning and how it can be used in order to develop privacy preserving cyber safety tools. And since we have, instead of having the monitoring and blocking features on the cyber safety applications, we suggest giving some filtering features that they can automatically detect the online threats by using machine learning algorithms in order to give less control over the minors' activities from their parents. So just by having some filters using machine learning models, we want to detect the online threats and notify the minors. But the challenge here is that most of the time, the data sets that are needed to train such models is the data is too sensitive, or sometimes we need to have again and again up-to-date data in order to follow the trends of the social media. So the idea was to use the federated learning instead of having decentralized machine learning, and instead of having centralized data set in a central unit, we have multiple clients, which are the users, and it can be the device of each user. It can be a laptop, it can be a phone, it can be a sensor, it can be a smartwatch or whatever. And instead of sending their data to a central unit to train the model, then instead we have the central unit sending the model to the clients, and then they need to train the data with their local data. And then just send back to the central unit the model updates. So we don't have the data leaving from the devices of the users, so we are following the privacy preserving value. So in the end, the model is getting trained without expose the data of the minors or of the users in any central unit. So we applied the federated learning. We did some experiments actually to build a model, a text classifier model to detect aggressive text. And I will just give some of the observations. Here's in the findings. We find that we can apply federated learning in the use case of cyber safety tools, since we were able to obtain a model with a good performance, which was similar or was approaching the performance of the model that was trained in the centralized approach. But we also find out that we need a lot of clients. That means also a lot of data and a big number of federated learning rounds in order to have the model to get trained and converge its performance. And we also had an experiment with some devices like my laptop, for example, to check how the laptop was allocating its resources during an NFL training, since I need to use my own resources to train the model locally and then send it back to the central unit. So that's it. That's what my thesis was about and what I was studying during my master's thesis and my master's studies. I'm currently, I've just started my PhD, so I think I will keep on working on similar topics. I will be glad to answer any questions if you have.
Thank you, Pantelito. Let me see if there are any questions from the chat. I hope I'm checking the correct chat. But I don't see question in case Antonio could just highlight question that I missed. But
No, I confirm there is no question.
okay, no, because I just have first, congratulations, Pantelisa, to be admitted to the PhD program. So it's really good that you did a master thesis in cybersecurity and you continue with a PhD. I think this is a really good path for you, but to encourage also for other young female, let's say, researcher. I have a curiosity about the model because my understanding is that your master thesis, you are going to exploit the results of the master thesis in your PhD work. You show a roadmap of, I guess, what you're going to do in the PhD. And I'm wondering, this tool, in which of the steps that you showed in the roadmap are going to be used if to, let's say, change a little bit the federated learning, or as it is, you're going to apply it?
Yes, you mean in the roadmap that I showed before for the how to build a more adaptive approach for them? Yeah, I mean there is. I mean, for sure, we need to find. I mean, the features are there. Many applications have many different features that you can find it, but I mean, you can find one application that has some of those features, and then some other applications have different features. So the idea is to try to collect them all together, and on some that we can work on, such as machine learning models that they can. I think I will work mostly on this automatic detection or filtering of the social media applications.
But the idea is to keep the federated learning, or it was, I mean, based on your experience in the master thesis, federated learning can be easily applied in this scenario on your roadmap, or it's something that you need to be considered?
I think we need to, it needs to be considered because you need to have the, I mean, the people accepting giving their data, or actually not giving their data, but train the models on their devices. So we will try to test that if it can work, because we have already implemented, I mean, in the lab that I'm working with, we have implemented these cyber safety tools, and we can try to install them for some, I don't know, families with minor children, and then check if that can work with a few data, and maybe in a combination with a centralized model and also with the. But yeah, it's something that I will work on.
Okay.
And study more.
Thanks for the nice presentation. Thanks, Eleonora, Martina, Pantelizza, for all the presentation. I'm hope, but I'm actually sure that this awards is just the first, one of the first achievements that you're going to achieve in your career. So hope to see you around. I'm sure that I will see some of you around. And so I leave again, congratulations. I don't see comments or chats, so I leave the floor. We are in the last session, so that's the point. I leave the floor to Antonio. I guess you are going to.
Yeah, sure. So thank you very much, Barbara, and all of you for this session. And I would thank you also, like the audience, for today. So we are going to meet tomorrow again at 10. So we will, I mean, you can join the platform all day long, so from early morning. And after this session, if you want, the lounge are open, if you want like to chat with other participants. And also like, please visit the exhibition area where you can find like between industrial booths, but also like research posters. So thank you very much to everybody and have a nice evening.
Thank you very much again.
Bye-bye.
Bye. Bye-bye.